Hello everyone. Welcome to this new tutorial series in which we are going to make an end-to-end flight booking system. We are going to use the technologies of Node.js and Express.js, and we are going to actually understand how you can make a microservices driven project in which you will be able to make your users book flights on your platform. Right. This is going to be a very interesting project because in this one we are going to understand some really deep concepts around backend development. A lot of people were actually requesting me to put this project on YouTube because this project has been the part of the earlier versions of the Lambda course, which is the ultimate backend development course. If you guys already don't know, then we have already launched the Lambda 4.0 backend development course, which is the fresh iteration of this advanced backend development course. In this one, we are going to make some really interesting projects, including a code sandbox clone. We are going to make a movie streaming app in which you can make a on-demand video streaming application. You can make a live streaming application separately, a social media like Twitter like backend, some interesting bots. We are going to make a Airbnb or booking.com like booking system, which is going to help us understand a lot of transactional capabilities. We are going to make applications like a URL shortener, Slack app backend. We are going to make a video call app. We are going to make a CRM application backend and whatnot. You can see a lot of power pack projects along with some really interesting concepts, keeping the approach as TypeScript first. We are going to have a TypeScript first approach, and we are also going to have a lot of low level design patterns in TypeScript. We are going to have an introduction to TypeScript and a very interesting module on introduction to Go as well. This is one of the best offerings that we have on Algocamp, and I would highly recommend you guys to check out the link in the description section below and use the coupon code backend to get maximum discount on this particular offering. It's going to be a live course, and all the prerequisites that you technically need in order to start with the course are already getting uploaded. So the moment you enroll in the course, you have something to learn. The prerequisite is going to be absolutely just JavaScript. You need to know the basics of JavaScript, but we have covered advanced JavaScript as well in this prerequisites. So you are going to have a really fun time in actually covering all of these concepts. So enjoy the remaining lecture in which we are going to build the project from scratch. It's going to be a multi-part series in which we are going to have probably put 4 to 5 videos in which we are going to make this project end to end. I hope you guys will enjoy it. And if you want to make more such challenging and interesting projects, do check out Lambda 4.0, where we are going to have really interesting discussion. And let's take your career one step ahead in backend development.
So I have prepared here a base Node.js project template. What I'm going to do, I'll do a basic npm init inside it, and then I'll be setting up all the major folders that we have already talked about here. Inside every folder, we'll mention one index.js file so that Git can also start detecting it. We'll set up Git, we'll set up our environment files, all of those things we are going to do, right? So I'll open this in VS Code. Okay, cool. Now, first thing that I would like to do is npm init. What npm init will do, it will help us to set up a basic npm project and will give us a basic package.json file as well. Right. So package name we are going to keep as Node.js project template version 1. Description I'll write as basic starter boilerplate project for Node. Oh, my bad. I guess there's a spelling mistake. I'll rectify it later. Git repository, don't want to mention for the timing. Author, mention my name. Is this okay? Yes. Okay. So now you can see we have a package.json file. I'll just rectify this. Okay. So we have a basic package.json file. I'll remove this test script for now because later when we will be actually setting up our tests, that will be the point when we will need some test scripts, right? So for the timing, I'll just avoid it because a lot of time it might happen that you don't want to write tests, or the time constraint is such that you will not be able to write tests. So it doesn't make a lot of sense to have tests written there, right? Now I'll also do git init. So we have initialized a basic empty git repository. Now what I'll do is I'll create a file git ignore. What git ignore helps us to do is, let me rename it correctly, git ignore. So whatever folders and files we are going to mention here, they are not going to be visible to our git repository. Okay. Now I will install a bunch of basic libraries that we need to get started with. So I'll say npm install Express, of course. Okay, I'll also install .env to manage my environment variables. I'll say npm install .env, right? And for the timing, this should be good. I will install one more package. It's a very interesting package that helps us to do a bunch of stuff. I'll show you guys. So a lot of time we have to deal with a lot of HTTP status codes, right? So you will find actually people writing status code in a very plain manner. For example, I'll show you how you can set status codes in using Express, but they just write 500, 201, 200, something like this. Generally, a good practice says that you should have a enum mapping of the name of the error code corresponding to the value of the error code. For example, you should have some enum like this. I'll just mention it here. For example, you should have some enum like success or okay. For example, okay should be mapped to 200, something like this. And then internal server error should be mapped to, let's say, 500, and so on. So you should kind of like have a JSON mapping or an enum mapping for this, because you don't want to write plain uh, error codes at any point of time. Because let's say you want to change the generic naming, or change, you by mistake made some mistake in defining the error codes, you want to change it, it becomes hard to actually keep track of at what all places you have used 200 or at what all places you have used 500, like that. And a lot of time you will actually find people also mentioning you that you should never put raw values anywhere, raw strings, uh, raw, I would say, numbers at any point of time. You should definitely bind them in some variables or some enums. That should be the better way to go for, in order to make a clean implementation out of it. So what you can do is you can use this package called as HTTP status code. It's a very light package and it does all the enum mapping for us already, right? So it's a pretty light package, not that heavy, and you can see fairly good amount of weekly downloads. And it's very cool. Like you just say status codes dot okay, reason phrases dot okay, status codes dot internal server error, and it is going to actually manage everywhere wherever you will write it. It will just replace it with 500. So we can also install that particular package. Um, so I can say npm install HTTP status codes. And you can see we have got HTTP status codes as well. Right. Now let's try to do a bunch of stuff with our project. I'll first of all make a .env file. Inside the .env file, we are going to write our environment variables. So I'll say port, let's say 3000. Okay. So we won't be hard coding our port in our index.js file. We will be using the port from this particular .env file. Okay. And we are going to make a folder source. Okay. And inside the source folder, I'm going to have an index.js file where my basic server configuration is going to remain. And I'll make one more folder called as config inside source. So you can see inside source, I have made config. See, inside source, I have made config. Now inside config, I'm going to write a new file, index.js. So we have a index.js inside the config folder as well, right? Now what we can do here is we can say const.env is equals to require .env. Okay, so I'm going to require the package .env and I'm going to call .env.config. Okay, what this does is at any point of time when you actually call this particular file, it is going to require the .env module, and it will, that .env module actually returns you an object. On that object, you need to call the config function so that you can actually get your environment variables in place. You can actually read about .env if you are not already aware about it. So whenever you have to manage some environment variables, right, you can actually use .env. It's very simple to use. Install it, create a .env file, and you can create your entries like these. And then all you have to do is require .env, and then it will return you an object. On that object, just call the .config function. The moment you do that, inside your process global, you have a property env. All of the environment variables that you have mentioned here are going to be loaded inside this object. So what I can do is I can say module.exports. I'll export out an object naming saying port, saying process.env.port. Okay. So now every file that we need a particular environment variable, we don't need to separately require .env there. What I'll do is all the exports I will do from .env, and I'll just import my config file and everything should be good to go. So what I'll do is const port is equals to require ./config, right? And if you are requiring from an index.js file, you don't need to specifically mention config/index. It will automatically pick index.js file only. Okay. And you can say const express is equals to require express. Now what I'll do is I'll make an express app object and we'll say app.listen on the given port, and we are going to pass a callback. We'll say console.log successfully started the server on port. Okay, as simple as that, right? So now what I'll do is I'll say node index.js, node inside source we have index.js. What's happening? Okay, it says address already in use. I know why it says address already in use. I have one more server already running on the same one. So let's restart the server. Okay. I have one project already running on port 3000, I guess. Just a minute. Now, if you want to run, you can see you have the source folder, and inside the source folder, you have index.js file. So if you do node source/index.js, you have a server successfully started on port 3000, right? That's actually that you can actually do, right? Now, a lot of times, a lot of people think that while you are doing npm install, you need to actually do minus minus save, right? So I would like to show you one of the documentations from one of the blogs of npm around in 2016, 17, I'm not sure. So if you search for minus minus save, okay. So npm will minus minus save by default now, right? So earlier you will find a lot of tutorials, if they are a bit old, people doing npm install express minus minus save or something. Now you technically don't need to do that, right? It's a by default functionality that is given already, right? Right. So you can see they have mentioned everything like this. And yep. So earlier minus minus save was actually used to add it as a dependency. If you just do npm install, it doesn't add it as a dependency in your package.json, but now it already does. So you don't need to actually care about minus minus save now. If you will see some old tutorials, they might still be using minus minus save. Now what I'm going to do is I'll set up a bunch of folders, new folder, for example, controllers. Then I'll make a new folder, services. Okay. I'll make a new folder, utils. We'll make a new folder, routes. Okay. Okay. These are the folders that we will get started with. Few more folders like models and migration and seeds will also come, but that is going to come up in a moment. Now, in every folder, I'm going to keep one index.js file. But you might be thinking why I'm keeping an index.js file. Let me show you an example. Let's say I make a home controller.js. Okay. And I'll make another new new file, um, about controller. Okay. Now let's say inside from my home controller, I'm doing module.exports. some function exec. Okay. Okay, some function I'm trying to export. I'll just cut it out here. Okay, I'll export exec. Okay, let's say something like this. And same to same thing, I'll do in home controller, this time home exec. Okay. Now the problem with having multiple controller files is that if you go to index.js, now you want to import about controllers function. So you'll say const about controller is equals to require. You will go inside the controllers folder and you will get just the about controller. And then let's say if you want to get the home controller also, you'll say home controller is equals to require dot slash controller slash home controller. Now just think about it. If you have, let's say 20 files, 20 controllers, then we will be writing 20 import statements. That's very bad. Like it's not even barely bad, it's very bad. Okay. So what technically we should do is, instead of like just directly importing them like this, we will be also having an index.js folder, index.js file. And inside the index.js file, we will write our manual imports separately. So let's say I'll export a about controller, which we will require from about controller. And then there will be a home controller that we are going to require from home controller. Okay. And what I'll do is, wherever I have to use any controller, I'll just import const object is equals to require dot slash controller slash index. And technically, if you don't even do index, it will automatically require index. And here you can see index.js file is actually exporting an object. We can destructure that object here. We can say about controller, then home controller. Whatever we want to require, we can require in a single line. That's it, right? So it makes the overall coding implementation a bit more clean, because here you are actually destructuring the object that you are actually sending from here, right? Instead of manually doing import of every module.export from every controller, you make an index.js file, export a bigger object out of it. Inside that bigger object, you are going to manually export every controller. And then wherever you have to use any controller, at that place, you don't need to write 20 require statements. You'll just write one require for your controllers folder that will automatically require the index file. And then whatever elements you want to get from that particular object, you can destructure the object and get only those particular keys. This is kind of like a good way to implement things, because this saves definitely a bunch of lines and improves the overall hygiene of the code. For the time being, I'll just delete these two files because these were for demonstration. Right. And here also I'll delete this. But I believe now everybody understands that why I'm going to create index.js files everywhere. So there also be a index.js file. Okay. And we will not write every time this slash index, this slash index. I will just write folder's name. Whenever you write folder's name, it will automatically by default assume that the import from that folder is going to be done for index.js file. Okay. Cool. Okay. Now I will like to make one more folder, middlewares. Okay. And index.js. Cool. So we have a bunch of files ready with us. Bunch of files and folders ready with us. Right. Okay. Now, let's try to talk about routes. Now, as we are going to make, most of the time we are going to make API driven applications, and API versioning is technically important, right? So what we are going to do is, inside our routes, we will be having routes in different folders for different versions. For example, I will make another folder, v1 routes. Then let's say if you want to have v2 APIs, I'm going to make a v2 route, right? Every different version of API routing, wherever the registration of APIs we have to do, we are going to do in different set of folders, right? This will help us to do actually API versioning very easily. Okay. Now inside v1, we will be having another index.js file. Okay, so you can see inside routes you have an index.js file, and then inside v1 you have index.js file. Okay, bunch of things you are actually doing here. Cool. Okay, now I'll do the registration of the routes. Don't worry. Like I'll fill up the code in these files. We will fill up the code in these files. For this, we need Express router. I'll talk about Express router, but I believe the routes folder will look good like this, right? And we are in a good shape with our project. Now, what we will do is, if you have node version more than I guess 18, then you definitely don't need this step, because there is something called as node watch, node minus minus watch. Okay, so with version 18.11, you have a new watch mode in Node. You can run your Node.js files with watch mode. What will happen is, if you will make changes to any corresponding file, it will automatically restart the Node project. But I am on lesser Node version. You can see I am on Node 16. So we don't have this functionality yet. So in order to avoid it, we can use Nodemon. Okay. We will use Nodemon. What will happen is, if you will use Nodemon, whenever you will do any project change, any folder change, file change, it will automatically restart the project. I'll do npm install Nodemon dependency. And if you want to actually start Nodemon, what you have to do is npx Nodemon source slash index.js. Okay, you can see it got started. Now let's say we will make a change in the folder. For example, I will remove this console.log and save it. You can see it automatically restarted. So what is the command? The command is npx nodemon source slash index. What is npx? If you have any package that you want to directly execute out of the JavaScript file, for example, in your terminal, if you want to directly execute any package like Nodemon, you can actually use npx, right? So you can read about npx here. So it says execute npm package, right? Npx stand for node package execute. It will simply it is simply another npm package runner. It allows developer to execute any JavaScript package available on the npm registry without installing it, and it is automatically installed. Like npx is automatically installed with npm version 5.2 and above, right? So you can actually directly use it. And if you want detailed description around what is npm and what is npx, you can actually start reading a bunch of articles, right? So you can separately also install it. And then whatever package you have installed, if you want to just directly execute it outside of your node project, you can use npx and then your package name. So we are doing npx nodemon source slash index. Now every time doing npx nodemon source slash index is going to be a bit cumbersome to do. So what I'm going to do is, I'm going to copy this command. I'll come to package.json, right? And inside this scripts, we are going to write a script. Okay, I'm going to write a script like dev. Okay, and then the key will be dev and the value will be npm nodemon source slash index.js. Okay, now you might be feeling, what is the benefit of it? Let me show you. Now you don't need to do npx nodemon source slash index something. All you can do is you can say npm run dev. The moment you do npm run dev, you can see it executes the same command, npx nodemon source slash index.js. So let's say we will be having separate ways to run things in development environment and production environment. So we can use different command for both of them, right? And you can make more scripts. For example, you want to make a script for testing. So you can make a test script that will do testing for you, and multiple other stuff, right? So this is how you actually configure scripts in package.json. I have made a script dev. All I have to do is just npm run dev. Inside this script, we keep the script name as a key. We will put a colon, and a value is going to be the actual command that you want to execute, right? And you can do anything. For example, if you do, let's say, ls, I'm not sure, I've never tried, but let's try. Let's say ls. Okay, if you do npm run ls, it runs lsc. It runs the ls command in your terminal. So it's pretty cool, pretty simple, right? You can configure whatever scripts actually you want. I'll just do npm run dev. Okay, so we have set up nodemon as well with us. If you have higher versions of Node, for example, 18 or above, you can definitely use something like Node Watch. Now let's try to do a bunch of more things. Now, generally, what do you do? Generally, let's say if you want to have a URL like this, app.get /API/v1/blogs, and then you put a middleware like this here, request comma response. Okay, this is generally a typical structure of how you actually define your routes. Now let's talk about this route that I have prepared here. /API/v1/blogs. Why we are prepending something with /API? Now there can be two type of routes. One type of routes can be API driven routes where somebody can use them as an API. Some routes can be non-API routes. For example, if you want to render a home page from your same Express server. Now rendering a home page is not going to be a API driven call. So for rendering a home page, maybe you can have something like app.get/home, right? Then you don't need to prepend this with a URL like /API. Okay. So that's why wherever you have API routes, you want to distinguish them with your normal routes, you can actually do /API. Then the next part is the version of the API that is currently v1. And then the next part is actually the resource that you want to mention. Now you can see, let's say if I have to make 5 routes like this, one might be, let's say, a post request, one might be a post request, put request, and so on. Like multiple requests are there. You can see everything is getting bloated in the same file, right? Everything is getting bloated in the same file. You will say that, okay, sir, these are controller functions. Why not you do something like you take all of this and let's say inside controllers, you make, let's say, a new file, let's say home controller.js. Let's say you start pasting them here. I'll say the problem still exists. In a controller file, we are also managing the routes. And just think about it. Now we have to write v2 routes also. V2 routes will also be clubbed something like this only, right? This doesn't look very tidy. Definitely this doesn't look very tidy. Okay. So what we have is we have a better way to manage things. Okay. Now, because Express is a middleware oriented framework, right? We can use a bunch of things regarding middlewares. But before we come to that, I would like to talk about something called as Express router. Okay. Express router. Okay. Now, what is an Express router? You can see routing refers to how an application endpoint URI respond to the client request. Okay. So wherever you have the word routes, they are actually referring to your endpoints only. Okay. You defined routing using methods of Express app object. That's what we were doing here, right? App.get, app.post, and everything. That correspond to HTTP methods. For example, app.get to handle get request, app.post to handle post request. Okay, cool. You can also use app.all to handle all HTTP requests. Now, if you want to make a URL that is independent of what type of HTTP method you are passing, you can use app.all. And there is something called as app.use to specify middleware as the callback functions. So if let's say, if we want to establish a middleware that should be applied to all of the routes written below it, you can actually do something like app.use. It mounts the specified middleware function or functions at the specified path. The middleware function is executed when the base of the requested path matches the path, right? So what you can actually do is, let me show you. I'll talk about Express router, and you can see there is something called as this app.use. So let's see what is this app.use going to do. Okay. So now there is something called as Express router also, which we will club with app.use. What is Express router? Express router class, use the Express router class to create modular mountable route handlers. A router instance is a complete middleware, and routing system. For this reason, it is often referred to as a mini app. You can avoid this line altogether. For example, the following example creates a router as a module. So we were also doing something like that, right? We are going to create these routes as a module. This is a separate module that we want to prepare. So the following example creates router as a module, loads a middleware function in it, defines some routes, and mounts the router module on a path on the main app. Okay, mounting means registering or establishing. Okay, so for example, what you can do is you can say, let's say you have a bird.js file. It's not the index.js file. Okay, it's a bird.js file. So you can actually require Express, and from Express you can actually require Express router. Now what will router do is you can actually do router.get, and you can have multiple URLs defined for router.get. For example, you have defined router.get slash router.get slash about, and then you have made your written your controller functions here. Now in your index.js file, what you can do is you can say app.use slash birds, and whatever is returned from the birds module, you actually mount that here. And what we are returning from the birds module, we are returning the router object. So what happens is now whenever somebody will make a request to slash birds or slash birds slash about, it will check, okay, the starting of the URL is slash birds. So we definitely need to use this birds router. Now, after that, there is nothing. So we need to use this get function. After that, there is slash about and it's a get request. We need to use this get function, right? That's the power of app.use and express router. So if you have to modularize your routings into separate folders for separate, I would say, entities and everything, then what you can actually do is you can make an express router. You can do route, instead of doing app.get, app.post, you can do router.get, router.post, and you can export that router. You can export that router. Once you have exported that router, then at any point of time, if you want to have a URL, let's say a prefix of a URL, and you want to mount a particular route after that URL, you can actually do that. For example, if you want to do slash bird slash about, so all the routes related to birds are in this file. Now, whenever you get something regarding slash birds, you can actually get that from here, right? And that's something that we are also going to do, right? Now you can see there is this use middleware also mentioned, router.use. It is similar to app.use. It says middleware that it specifies to the router, right? Now inside this router, if you want to specify a particular middleware, you can do router.use, and what will happen, this middleware will be applied to every route in this file. Every route in this file will get this middleware, right? Similarly, every route in this file is going to get this middleware, but this middleware says that uses, whenever you get a route with slash birds, then you mount it. If you get a route without slash bird, it will have no effect there. So summary, what is app.use? Using app.use, you can register more middlewares. You know how to register middlewares directly in the URL, or I would say directly in the app.get or app.post function. But now if you want to register a middleware for all of the routes somewhere, you can actually use app.use and pass the middleware. Now app.use does one more thing. It can actually help you to mount a router. If you pass the argument such that you have a string which denotes some URL and then you put the router object here, it will mount a router corresponding to this particular starting URL. And what is a router? Router is an express class that can help you to create modules for your routes, right? And this is something that we are going to now implement as well. So in the index.js file, let's try to use our router. So inside index.js file, I'm going to register saying app.use slash API, and I'll say API routes. Okay. I'll import API routes from the routes, and whenever somebody will give me a URL that starts with slash API, I'm going to redirect all of those requests to the API router. Okay. Let's require it. Const API routes is equals to require dot slash route slash index, and we don't even need to mention index. Okay, so from our index.js file of our routes folder, this one, we are going to actually export a router object. In that router object, all the API driven routes should be mentioned. So let's come here and let's start implementing a bunch of stuff. So I'll say const express is equals to require express. Okay, and then I'll say const router is equals to express.router, and we will say router.use. Now, if at any point of time you got slash v1 after API, then we are going to redirect them to v1 routes. Okay, we will import v1 routes as well. Const v1 routes is equals to require not slash v1. Okay, so inside the v1.index.js file, we are going to write our version 1 routes of the API. And now what will happen? If somebody gives you slash API, you are going to redirect that request to API routes. Inside API routes, after slash API, if somebody gives you slash v1, you are going to redirect that to v1 routes. Okay, let's do one thing. I'll do module.exports and I'll just export the router object, because here we have registered the middleware, right? And now let's go inside v1. Okay, now we have the v1 file. Inside v1 file, we will again set up our express router. So const express is equals to require express, and then const router is equals to express.router. And let's say I'll set up my first API. I'll say router.get slash info. Okay, slash info. Request comma response. And let's say I'll say return response.json message. Okay, cool. And I'll say module.exports route. See, whatever they did in the birds example, I'm doing as it is same. See, they are defining a bunch of router.get and something. I'm exporting that route. So we are inside v1 index.js file. This is the router for v1. Now we are inside routes index.js file. This is the router for routes. And then here we have our overall app registration. So now what will happen? If somebody gives me localhost 3000 slash API slash v1 slash info. So I will first of all check, okay, does the URL has a part slash API in the start? Yes. So we are going to redirect ourselves to API routes. Now, after slash API, do you have slash v1? Yes. So you are going to redirect yourself to v1 routes. Now after slash v1, do you have slash info? Yes. So you are going to actually execute this GET request. Okay. Let's actually see this in action. Okay. So npm run dev. Let's open Postman. And let's say I say localhost 3000 slash API slash v1 slash info. Slash info. Right. Let's send this request. And you can see we are getting message. Okay. Right. And everything is working fine. So we can use actually this router.get slash info to actually see whether our API is working fine or not. For example, when we will deploy and we just want to check whether our server is alive or not and everything, I can just do a slash info and it will return a message. Okay. Now you can see this is a controller. This is a controller. And I have written the controller in the same file. I have written the controller in the same file. It might be a good time to segregate this also into a different controller altogether. Now you can actually see inside our v1 routes, we have this controller. I don't want this here. So what I'll do is I'll delete this home controller altogether. And I'll make a new file, info controller.js. Okay, whatever details we will require for information regarding the overall API and everything, we might want to send it through a info controller altogether. You'll say module.exports, something like this. And now I'll make a function const info is equals to request comma response. Okay, const info is equals to request comma response. Right, you can make it an arrow function, you can make it a normal function. It's not going to have much of a logic, so I'm just making an arrow function altogether. From here I'm going to say return res.json. Okay, now in the JSON I'll be having some properties like success true, message API is live, there is no error, so error will be empty, and we don't need to send any data, data will be empty. So generally, whenever we have API responses, we try to maintain some common API response structure. So generally what structure I follow is I keep a success parameter in the return response.json, because if somebody just wants to check whether the API is successfully executed or not successfully executed, they can just check it using a single variable success. If I want to send a custom message in order to educate the end user, I can do that. If there was specific error that happened and I want to expose what error actually happened in detail, this error key value object can be helpful. And if let's say we wanted to fetch some data or we wanted to get some data, post some data, and then we have some good data response that is not related to any error, we can use this data property. So we are going to use this common response structure everywhere. Okay, but for the time being, you can see this looks like a controller function. Now what I'm going to do is I'm going to export it. I'm going to export info, and because key value pair is going to be the same name, so I just can put the name of the function, value will be automatically the function. Now I'll come to v1 routes, and now you will see things in action. I'll say, first of all, before going to v1 routes, inside this, I'll say info controller as require info controller. Okay, so inside my controller index.js file, I have exported an object inside which we have a key value pair info controller, which requires the export of info controller.js. Now we will go to v1 routes and we say const info controller is equals to require. Now we are inside v1 routes, right? So we need to go one folder back, we are in routes. We need to go one folder back, we are in controllers. And now you get controllers, and from that you are getting info controller. And now you can actually replace info controller.info. You can see how clean things look like, right? We have segregated out our controller altogether outside. Okay, so you can see server is automatically getting restarted, don't need to manually restart. And if you send, you're getting a good correct response, nothing more, nothing less we require from that. And that's how we have set up our first basic API. And things definitely look cool here, pretty segregated. You can see API routes / API, and now definitely you can have some server side rendering based layouts if you want to have some layout based routes. So you can have some prefix for that, you can define it yourself. I don't see any recommendations already for that. And then inside your routes, you're actually having v1 router. Now just think about it. If you want to have v2 routes, you'll make another route of routes folder v2, and here you will require those v2 routes, and then you'll just directly say router.use /v2 comma v2 routes, and you will be able to start exposing v2 routes as well. So anybody can do /API /v2, something like that. And then inside v1 you have a router.get /info, which is pointing to a controller function which we have completely segregated out, and the implementation definitely looks pretty clean. There are some style guides around how file naming and everything should be done, right? So there is a Google style guide that you can actually see, which says that file name can include the dashes or underscore, all lowercase, and extension should be .js, right? So we were already following this kind of a convention, but I don't think there is some specific one that everyone wants to follow. You will see people actually doing multiple things, But this one is something that a lot of people, I have at least myself seen following. You can have everything lowercase followed by a dash in between every word. This can be a good way to implement, right? But again, for example, some frameworks might impose a bunch of things. For example, if you go to React, in React, component names needs to be of capital letters, right? They mention that as far as I remember. So until unless things are imposed on you, you don't need to be very strict on anything. You can follow any style guideline for that. Now a few more cleanup that we might have to do. Now here you can see when you're doing rest.json, first of all, I love a semicolon here. When you do rest.json, you can see it is already automatically returning a status code 200. Okay. We are not manually anywhere mentioning status code 200. Now, a lot of time you will see people sending something like code 200, something like this. But technically, you don't need to do that in Express.js. In Express, you have a very cool way of defining status code. In the response object, you can say response.status, and then you can say any status code, for example, 500. So see what I have done. Rest.status 500.json. Okay, I'm just showing you a demonstration. Okay, if I send, you can see it automatically takes the error code. So what happens is the response object has a status function. This status function actually sets the status code, and this status function returns the same response object. That's why this returns the same response object. So on the same response object, you have a .json function also, because without this .status also everything was working, right? Rest.json, because response object has a JSON function. This .json, .status, all of these functions, what they actually do is when you do, let's say, rest.status, it sets the status code and returns the same response object that it has updated. Then on that response object, you call the .json function, it sets the JSON, and then it again returns the same response object altogether. So if you will actually go to the definition of status and .json in Express, you will actually find that it is returning the same response object. And why do you need to know this information? Because when you will be mocking, like when you will be doing unit testing, this piece of information will be required to mock all of these. If you don't know what is mocking, don't worry, we will talk about it. But what I want to explain here is that when you actually do rest.status, anything, this actually returns the same response object. And on that response object, you are technically doing rest.json. And this also returns the same response object that we are actually returning. This is something that you have to always and always keep in mind, right? So that being said, now I don't want to have raw error codes here. So for that, we already have a package. We can say status codes from require HTTP status codes. And let's say now you can do actually status codes dot, let's say, internal server error, for example. Now it must have refreshed automatically. Yes, if you send it, now you can see we are getting still internal server error. If you say status codes dot not found, okay, you can see automatically changes not found. But what do we want? We want okay. We have 200 okay, right? So this can be a fairly simple and good implementation to actually go for, right? You can actually also, if you want, keep it everything in separate line, but I want to keep everything in same line. You can have your own linting rules if you want to describe. But I believe now things look pretty better, because now all the status codes are also wrapped in enums. You don't have plain raw status code lying around here and there and just doing whatever they want to do. And things are pretty good, right? So after this, what I'll do is I'll do a bunch of more things. For example, now I'll create a new folder, repositories. Okay, I'll create a repositories folder, which will be having an index.js file in itself as well, module.exports. Okay, so one repositories folder is there. Now I need to set up a few more things. You might be feeling like, okay, how much more? As I'm saying that we are preparing kind of like a starter template for us. whenever we have to start with an Express project, we will just download it and we'll start get going. Okay, so we need to, that's why wrap up everything. Now, first thing is, if you want to actually upload this project on GitHub, we should not upload node modules folder at any point of time in any npm project. You should never upload your node modules folder because it is very heavy. It can actually increase the overall size of the package and everything. So now git ignore will be helpful for us. What you can do is you can write node underscore modules. The moment you write node underscore modules, you can see it automatically grayed out because now git is not tracking it. You can actually check it as well. Git status. You can see now it is not getting tracked inside git. And the next file that you don't want to track is .env file. Okay. The moment you do .env, this also grays out. If you do git status, now you can see previously .env was getting tracked. Now .env is not getting tracked. So these two files we are going to keep untracked. These two files and folders we are going to keep untracked. Sorry, my bad. You can see now .env and node modules both are gone. Everything inside the source folder we are going to track, right? We might need to have some more files or folders that we want to avoid, but we will take a look at it at any point of time when we will require it, right? So this was one more thing that I wanted to do. Now what we want here is that like generally whenever we will be having some coding implementations, definitely there will be some bugs, and we would like to have good logging information coming out of those bugs so that we will be able to debug it well, right? So in order to handle that, there is a package called as Winston npm. We are going to integrate Winston, and what we will manage is we will manage a very small log file, right? That we will see how to implement. So you can see it's basically for good logging and everything. It helps you to have different types of formats and information levels and everything. So you can definitely actually do that, right? So let's install Winston. So we'll install Winston. Okay, Winston is there with us. Now what I'll do is inside the config, currently I have index.js. I would like to segregate it a bit more. Right. That means what I would like to have is I'll like to have a server config.js. Okay. And whatever is our current coding implementation, I will pass on that to the server config, right? And here we will do module.exports server config as require /server config. Okay. And inside our index.js file, now port will be not directly available. We need to have server config, and we will say server config.port. Okay. Let's try to do npm run dev. This should be server config.port. Okay, everything is working fine. Now what I'll do is I'll make a new config file that is going to be my logger. So logger config.js. Okay, I'm going to define a logger config where we are going to set up Winston, right? There's a very standard Winston template setup that we are going to use, right? So if you will actually see Winston's doc, and where I am getting all of this information from, of course, Winston documentation, right? So technically what Winston helps you to do is, let me show you. So there are a bunch of things. For example, yeah, this one, I generally try to use this one. So Winston provides you a bunch of formats in which you can actually do your logging, right? In order to do that, you need to require Winston, and you need to destructure the object to get a create logger function, create a format. I guess it's a object. We'll check. Yeah, it's a format is also an object. And then there is this transports, right? So what we will do is we will require this particular line. We don't need to go into much of the details why we are doing it. It's just like, this is how Winston setups its old format. Then you need to actually get all of these from the format object. So what we are doing is we have all of these objects. Create logger is a function, rest both of them are objects. Then we destructure the format object in which we get a label, a printf function, a timestamp, all of these things. And now what I can do is I can define a custom format. I can define a custom format which will be equal to, let's say, printf. Printf helps to actually print a particular log, right? They must have done this. You can see printf, which actually takes, you can see, a function as an argument. So it takes a callback function as an argument. Inside this callback function, you get an object which you can destructure. You will pass a level, message, and the timestamp. Okay. Now, what is level? Level is the severity level. For example, whether this is a information log that, for example, you wanted to create a blog got successfully created and you want to log it. So you will say an info log. Then let's say there is some error log. So you will, the level of the log is going to be, let's say, error. Okay. Then let's say there are some warning logs. So the level of this particular log will be warning, right? So you can actually see that here, right? You can pass any kind of a label. It will just directly take that. It is just that it is going to help us to understand how the labeling and everything works, right? Then there is this timestamp. What timestamp is going to help us to do is timestamp will actually print when this log happened. So generally when you are in production level code and you want to do some debugging, you want to actually see, for example, don't want to read the whole logs. You just want to read the logs from one particular day to another particular day, in between which some error happened. You don't want to see the logs of 30 days back. It's like that, right? So it's good to have timestamps as well. And then this format you are going to pass, which is actually going to print the log in the form of, first of all, timestamp. Then there will be a label along with a level, and then there will be a message. Okay. So I'm not keeping label, I'm just keeping level. Okay. You can also keep label. Let's keep label, no problem. Let's keep a label as well. Okay. And we might use a same format. So we're using the same format. I'll just put a semicolon in between everything so that we can separately segregate. So in the timestamp, we can print the current timestamp. In the label, let's say we can actually mention which module or which particular folder the error came from or something. Then level, severity of the error or severity of the log, and then actual message of the corresponding log. Right. So again, if you don't get much of it, don't worry. It's just like a standard templating that we are doing for Winston. Now we are going to create a logger function. Create logger. Right. Inside create logger, you pass an object. Right. You have a format. So now in the format, all you have to do is there is a function called as combine. Right. So you need to pass a combine function. This combine function takes a timestamp. You can actually see that here as well. See, it takes the timestamp, then it takes everything around the label and everything. So you can pass everything like this as it is. Okay. Let's pass as it is everything. Okay. So and let's do one thing. We don't need this label. We can avoid it. And this is custom format. Variable name is different. Okay. Now in the timestamp, I want to have a timestamp with year, month, date, hour, minute, second, so that exactly we can get when something happened. So in timestamp also, I can mention the format of the timestamp. It should be y. Then it should be month, date, and hour, minute, second. Okay. This is how I'll keep the timestamp formatting, right? And this type of timestamp formatting is going to be used in the custom format, which we are actually printing here, right? Okay. Now, the second argument of this create logger function is transports. Okay, transports. Now, what is transports? This is the only piece of information that you need to technically understand in this whole file. Now, what you want is you want your logs to be printed on the console also. And let's say for later debugging, you want your logs to be stored in some log files as well. Okay. You want to store your logs in some log files as well. Okay. So what you can actually do is you mention all of the streams where you want to actually put your logs inside the transports array. Okay. So for example, we want to have new transports.console. This mentions that if you will use Winston, it will only print on the console. If you pass another transports.file, and then you pass a custom object with the file name as, there's a file name property, and I'll mention at combined.log. So I'm going to have all the logs combined in one file. I'm not making separate log files for everything, right? Let's keep it simple. And that's it. So now what will happen if anyone will use my logger function, the logs will not only just come on the console, but they're also going to come on the file that we have mentioned here as combined.log. Okay. And now from here, we are going to do module.exports logger. Module.exports logger. Okay. Now you can see there is no combined.log file. You can see there is no combined.log file, right? Let's come to index.js. And now what we can do is, first of all, inside my index.js file, I'll say logger require ./logger config. And what we'll do is we'll import a logger. As simple as that. So this is how we will import the logger. Now, if you want to actually use a corresponding logger, it's going to be pretty easy to actually use. All you have to do is just call the logger function, just call the corresponding logger function. Once you have called the logger function, you need to just pass the severity. You need to just pass, for example, what is the actual error code. All of these details you can just pass and everything should start working fine. Okay. So actually let's try it. Let's try it. So now what you can do is you can actually say logger dot info. So it is already going to take info as the level. You have more levels, for example, logger dot error, logger dot warning, all of this. I'll do logger dot info, right? And then you can pass some error, whatever you want to pass. So for example, let's see, we have message label timestamp. Message is successfully started the server. Okay, then you can pass a label. Label can be, let's say, root, because it is from the root index.js file. And the error object can be empty, right? You don't want to have any error or something. And that's it. Okay, see, nothing is there. The moment I save the file, the moment I will save the file, can you see the logs are coming as, first of all, there is a timestamp, then there is info, then there is successfully started the server, and then there is this undefined. Let's see why there is this undefined. Because we are actually getting the label. So let's avoid label altogether. I guess we don't need the label. This should be enough without the label only. Okay. And here we don't need to pass the root because all the information we need is already there. Now you can see this is an info log and this is the corresponding log. Successfully started the server, right? If you see combine.log file, you can see this is how your log file will be managed. So later in time, when you will actually want to debug something, you can actually very easily debug it using this corresponding logging mechanism. And let's say you want to have, let's say there was some error, right? Let's try to do something like this. Let's try to print a custom object message something. Save. Let's see combine.log. Okay, it's not showing the message, right? Let's see why it's not showing the message. So maybe what I can do is I can later set it up that it takes along with a string and error object also. I'll try to do a bit of debugging. Let's not blog us there. And let's move forward. But for the timing, we can actually see we have our logs actually set up with us. We will be having a dedicated log file. And we definitely don't want to push this log file also. So I'll say combined.log. Okay. And now this log file will also not be pushed on GitHub, right? We can write a mechanism separately that can refresh our log file after, let's say, every 5 days or 10 days, because you don't want to maintain a log of like 10 years back. Generally, people refresh their logs around after 30 days. We can maintain on a small scale around 5 days, something like that. Otherwise, this log file will become huge. Generally, people have separate logging services if they have a very, very huge project, but we don't have that use case for now. So that's how you can actually set up your logger. I'll avoid it from this server restart statement because otherwise it will use it a lot. And anywhere, anytime we have to use a log, we can do logger.error or logger.info. Our loggers will work. I'll see that how can we actually update our logger so that it can also print multiple things, because currently our logger statements are clean. I just want, if there is an error, some error details we can also print together, but we'll see that later. Okay. Now, what is an ORM? ORM is something that we are going to set up our project with, right? Now, generally, there are two concepts, ORM and ODM. There is something called as ODM as well. Okay. ORM is generally for SQL database. ODM is generally for NoSQL database. ORM stands for Object Relational Mapper. ODM stands for Object Document Mapper. Now, once you understand ORM, ODM will be automatically understandable. Now, when you write SQL, when you have to interact with your SQL databases, your SQL databases, then you write something like create table name. For example, you have to create a products table, you do create products, create table products, and then you put a lot of properties. When you have to insert a product, you will say insert into products, you put the column name and then put the column values. Now, all of this is a very MySQL-ish or a SQL-ish syntax. It's not object oriented, right? And of course, we are fond of doing things object oriented. Anywhere at any point of time, if we can do something like new object or object dot some message, we understand the code better. So what ORM is, ORM actually acts as a bridge between your MySQL syntax and your object oriented syntax. And what it does is provides us an interface using which you can write object oriented code, which will internally be automatically converted into a SQL based code, and then it will execute your SQL. For example, let's say if you have to do insert into product, that means you need to create a new product, right? Instead of that, you can do product.create. Instead of writing your raw SQL like insert into products, you can do product.create and everything will start working fine. So the ORM, that there are multiple ORMs, to be very honest. Sequelize ORM is going to be something that we are going to use for our projects. It's a pretty good ORM, pretty stable, and it has got a tons and tons of features, right? There are other alternatives also. You can actually Google alternatives for Sequelize ORM. Okay, you can see type ORM. Mongoose is an ORM for MongoDB. Like if you want to integrate with MongoDB, Mongoose is an ORM. And you can see there are a bunch of them. Type ORM and Sequelize ORM are the one which I have heard most for. And Sequelize is definitely one of the accepted ones. You can use anything. It's again just a bunch of configurations, right? And what Sequelize will help us to do is, for example, if you want to insert a new entry in the user table, you do insert into users email, password, date of birth, and then you pass a@b.com 1 2 3 4 5 6 and then 1st Jan something. This is a raw SQL query. But instead, what you can actually do here is you can say user.create an object oriented syntax. And then you can pass a custom object in the function. Username is the column name and you pass the username. Birthday is the column name and you pass new date and all of this. If you want to get all the users, you do select star from users. But that's again not an object oriented syntax. What you can do with an ORM is you can do user.findAll. See, it becomes pretty understandable that you want to get all of the users. And it gives you a promise based syntax. So using async await and everything is going to be pretty cool. And it helps you to actually define your schema and models as well. For example, if how your user table should look like. When you actually create the table, you define the overall schema, right? So you can define that schema like this using Sequelize directly, right? And it helps you to do a lot of things. For example, it helps you to do data modeling. For example, you can actually set up how your schema should look like. You can do associations, for example, one to many, many to many associations you can do. You can do things like soft deletion, a lot of features it actually comes up with, right? And you can actually read the overall docs. If you go to getting started, you can see there are a bunch of functions. There are things like eager loading, right? There are associations that you can actually set up, and these associations are going to be pretty cool. For example, let's say a category has many products. You set up this association with Sequelize. Now if you want to get all the products of a category, you don't need to write a join. You don't need to write a join query. You can just say category dot get products. It will automatically give you all the products. See, that is the power of ORM, right? And a lot of things are pretty optimized in ORM. I'll talk about some of the optimizations as well that it does, but it's going to be pretty easy to set up, right? You can actually see that here. You need to just do npm install Sequelize and you can actually start using it. But apart from just installing Sequelize, you need to also install a driver. What is the driver? Now Sequelize is an ORM for any type of relational database. Now the relational database that you might be using might be MySQL, PGSQL, SQLite 3, MariaDB, Oracle SQL, anything. So how SQLite will know which database to connect and how to connect, because there can be different databases. So for that, you need to use a driver that, okay, in my project, I might be making you connect to a MySQL database. So for a MySQL database, the driver is MySQL 2. For a SQLite database, I guess version is also SQLite 3 only, and the driver name is also SQLite 3. For MariaDB, it is MariaDB. Okay. So whatever database you are using, it needs a driver to make a connection from the ORM layer to the actual database layer, because there are different databases. Not every database has the same way to do the connections or do the queries and everything, right? Every database might be exposing different ways of optimization, different ways of doing the queries. That's why this driver is actually needed. So you will install the driver and then most of the things will be good to go. Now still this node based ORMs are not that, I would say, powerful if you compare them with Rails based ORM. So Rails has an ORM called as Active Record. Now why Rails based ORM is very powerful? Because you need to do very less stuff in Rails based ORMs. Here you have to install it and you have to write a bunch of code to execute a lot of stuff. But I will help you to actually make it quite comparable and quite powerful as other big frameworks. I would say ORM like Rails Active Record or something, right? I'll help you how you can actually make it as powerful as that, because it is still very powerful. If we can add some part of automation to it, it will be definitely significantly powerful then. So we'll talk about that how you can actually do that. But this is something that we are going to integrate next in our project. But before that, I'll just upload whatever is the current situation of the project, and then we'll make another commit over it. Base node project template. Okay, let's see our git ignore is good. Yeah. So git add all, git commit -m, added basic node functionalities. Oh, sorry, added basic Express functionalities. Right. We'll add the remote, git push, origin master. Okay. If you refresh, so on this link, you will find your basic node project, right? Most of the folders are there. There will be more folders added. For example, migration, seeds, models, and everything will be added. That will add once we set up our ORM. But that's going to be happening in the next part. Now we will quickly revise what is our current folder structure, and then we are going to start a bunch of things around integration with ORM. Okay. Now, if you will carefully see, you have this kind of repository structure. There is a node modules folder and then there is a source folder. Later, of course, you would like to add something like a tests kind of I guess tests should be a good name, tests kind of folder, but that will come up later, right? Currently we have source folder, all the actual source code where we are going to write all of our core implementations is going to reside inside the source folder. Okay. So what I can do is I can just quickly create a README file. Okay. And inside this README file, I'll talk about the whole project structure. Okay. This will also help you to understand what is actually going on. So this is a base Node.js project template, which anyone can use, as it has been prepared by keeping some of the most important code principles and project management recommendations. Feel free to change anything. Okay. Now, if you will see, there is a source folder. Inside the source folder, all the actual source code regarding the all the actual source code regarding the project will reside. This will not include any kind of tests. Okay. You might want to make separate tests folder. Okay. We'll talk about this, that why do you want to do that later. Okay. Now inside the source folder, let's take a look inside the source folder. Okay. Now inside the source folder, you can see we have lots and lots of things. Okay. We are going to go through everything one by one. Okay. So first of all, we have a config folder. In this folder, anything and everything regarding any configurations or setup of a library or module will be done. For example, setting up .env so that we can use the environment variables anywhere in a cleaner fashion. This is done in the, you can say, server config.js file. In the server config.js. Okay. One more example can be to set up your logging library that can help you to prepare meaningful logs. So configuration for this library should also be done here. Okay. This is going to be the use case for the config folder. Now let's talk about the routes folder. Okay. Let's talk about the routes folder. In the routes folder, we register a route and the corresponding middleware and controllers to it. Okay. So what you are technically doing is you're doing nothing, but inside the routes folder, you register a route that, okay, this is an available route in my Express application. And with this route registration, you also bind which controller or which set of middlewares should be triggered when you actually go or you actually make a call to this particular route. This is the only thing that routes folder is doing. It's registering a route, and apart from that, it's also binding the corresponding set of middlewares and controllers that needs to be executed one by one when somebody actually calls that route. So what actually goes on in the routes folder is you actually try to modularize your route registration and controller bindings. So you use the Express router because Express router actually helps us to segregate out routes in different modules and then club them together wherever we want, right? So that's why we are also exporting just the router object. In this particular line, we are registering the route that what should happen when somebody actually makes a request to /info with a get request, what set of middlewares and what set of controllers should be executed. Currently I have not registered any middleware, only a controller, so that controller I'm actually mentioning. Now the next folder that we had is simple, that is middlewares. They are just going to intercept the incoming requests where we can write our validators, authenticators, etc. And then we can have controllers. They are kind of the last middlewares. As post them, you call your business layer to execute the business logic. In controllers, we just receive the incoming request, incoming requests and data, and then pass it to the business layer. And once business layer returns an output, we structure the API response in controllers and send the output. Okay, cool. This is the use case for your controllers, right? Now inside our routes folder, we have a v1 folder. This v1 folder we are making because we want to make a v1 route. That's for API versioning. Let's say after some time you want to make v2 routes, that is version 2 of your APIs. So what you can do, you can make a v2 folder. Inside your v2 folder, you can, let's say, make an index.js. Here I can say const express is equals to require express. Const router is equals to express.router. Router.get /info. And let's say I'm writing a inline controller only. Request comma response. Return rest.json. Message coming from v2 API. Okay, something like this. And then I'll do module.exports router. Okay, I'll export the router. Okay, so now let's say you have now started preparing. Now inside v1 API also you have a /info, and inside v2 APIs also you have a /info. Now if you go to routes index.js file, this particular one, here you have registered your v1 routes. Now what I can do is I can register my v2 routes also from /v2 routes. And then now what will happen is if somebody will ask us /API /v2 /something, we are going to redirect our request to v2 routes. As simple as that. See, from index.js, if somebody gives us /API, we go to API routes. In API routes, if somebody gives us after /API, if somebody gives us v1, we go to v1 routes. If somebody gives us v2, we go to v2 routes. And in both the routes, we have info. Okay. Now let's do one thing. Let's start our server, npm run dev. Okay. Now let's open Postman. And in my v2 routes, I'm not specifically making a controller because I'm just showing a demonstration. I'm going to delete this whole v2 route folder. That's why I wrote an inline controller. This is just for demonstration purpose. Now let's say if somebody will make a request to /API /v1 /info. This is currently coming from our v1 API. Now, let's say we migrated our API, we made some new features and everything. All they have to do is now start asking for V2. You can see this is coming from V2 API. As simple as that. So this is how you can very easily do API versioning. The end user won't be affected a lot. That's why we have kept this V1, V2 folders as well, right? So now I'll just delete this folder altogether, move to trash. And here as well, I will just delete it because we don't need it now. And here as well, right? So this is the major use case for your routes folder, controllers folders, and your middlewares folder. One more folder that you have is repositories. This folder contains all the logic using which we interact the DB by writing queries. All the raw queries or ORM queries will go here. As simple as that. Okay, that's your repositories. Okay, services is your business logic. Services contains the business logic and interacts with repositories for data from the database. As simple as that. Okay, and utils is just for your helper methods. Utils contains helper methods, error classes, etc. Okay, all of these things. Okay, so this is the current folder structure that we have, and I believe the logic behind most of the folders is now clear to everyone. Now we already know about basic ORMs. So ORM, what it is going to help us is, it is going to make sure that whenever we have to write SQL queries, we don't write raw SQL queries. We are able to maybe write some object oriented code for it, right? Instead of writing plain raw queries, because who likes plain raw queries for everything? Maybe you have a very complex logic. In that kind of a case, maybe a plain raw query might also help. I'm not saying it's of no use at all, but in case that you have very simple queries, then a bunch of object oriented stuff might definitely help, right? In order to do that, the ORM that we are going to integrate is going to be Sequelize. Okay. Now, how you can set up this Sequelize ORM? Let's talk about it. So if you go to getting started, first of all, you have to do npm install Sequelize. You don't need to do minus save. Of course, I've already talked about that in the latest version of Nodes. You don't need to do that. So let's open it on our terminal. Okay. Npm install Sequelize. Cool. So we have installed Sequelize, but just installing Sequelize will not help, because Sequelize is the ORM. It will help you to convert your SQL queries, your RDBMS based SQL queries, to object oriented code. But the RDBMS behind the scenes can be different. It can be MySQL, it can be Oracle SQL, MariaDB, SQLite 3, anything. In that case, Sequelize might need different kind of interfaces to actually connect to the database, right? So what we need to do is we need to install a driver. The driver will actually help Sequelize automatically understand that this kind of a database is going to be connected, and what code or what coding implementations it needs. It will directly fetch it from these drivers and connect to your database. So we are going to integrate things with MySQL. So we need this MySQL 2 driver. Don't ask me why they call it as MySQL 2, because maybe this is the new version of the driver. I'm not sure. Okay. You can install MySQL 2. And technically, at a very good scale, you are ready. But the thing is, If you'll start reading the Sequelize documentation, you have to do a lot of code setup for Sequelize. For example, you can see you have to do const Sequelize, then all of this SQLite memory stuff and everything. All of these things you have to actually do, right? Then you have to actually start preparing your database path, storage path, and then put some dialect. This dialect you have to mention as MySQL. Like a lot of coding you have to do. If I open my GitHub, what I want is if anyone has this base project template, they can get started with it. I don't want my users to be bombarded with all of these information that, okay, if you are using this, then you should do this, then you should put this URL here, that URL here. I don't want to do that kind of a stuff because it creates a bunch of hassle. Then if you have to connect, do the connection, you have to do something like this. A lot of steps are actually involved. We don't need to do that. If you will go to the world of things like Rails or Django, ORM integration is very simple because they actually do it behind the scenes automatically and we don't have to make a lot of effort. In Sequelize by default, we have to make a lot of effort, but there is a package that Sequelize themselves support in order to make yours and our life easy, called as Sequelize CLI. If you open the GitHub repository of Sequelize CLI, you can actually see who manages it. Sequelize themselves manage it. So it's definitely not a third party one. Like it's not something like somebody else did it. It's updated 5 hours ago when I'm actually doing this particular part. So you can actually see last it's updated on May 1, 2023. So it's people are actually very frequently working on this open source project. And Sequelize CLI will make your life the easiest possible. You will never have an easier life after having things around Sequelize CLI. Okay. What Sequelize CLI actually does is it gives you a bunch of commands, and these commands are consistent with commands of other frameworks as well. For example, there is something called as DB migration. I'll talk about what is DB migration. You do Sequelize DB migrate. A same to same command actually exists in Rails called as Rails DB migrate. Okay, same to same command actually, migrate. So if I show you db:migrate, you can see Rails DB migrate. You have a same command here as well. If let's say you have to, let's say you have to create a database, you can do DB create. If you have to drop a database, you can do DB drop, right? Lot of things you can actually do directly from here. And these are going to be just a bunch of simple commands that you have to actually do. Nothing more, nothing less. If you have to create a model, for example, let's say you have to create a blog model, you can do Sequelize model generate. If you go to the world of Rails, then Rails generate migration, and you will also have Rails generate model. See, there you have to do Sequelize generate models. Here you have to do Rails generate model. So see, Sequelize CLI has been made such that the commands are very consistent with other frameworks as well. So if you are coming from some other background of, let's say, Laravel, Rails or something, you will find these commands very handy, very easy, and they are going to do a lot of things automatically for you. And this is something that we are going to use. We are developers. If we are making a template like this, we don't want our users to hustle a lot on this. So we are going to use Sequelize CLI, and let's see how you can actually integrate Sequelize CLI in your project. So if you want to actually set up Sequelize CLI, right? Why we want to use Sequelize CLI? Because a lot of things Sequelize CLI will automatically do for us. We don't have to go through the hassle of creating our own database configurations and everything. It will generate a lot of files for us. And when we have to even create schema models and everything, it will automatically generate everything for us. So I'll just copy this Sequelize CLI command from here and I'll install it. I don't want to just save it as a dev dependency for now. I'll talk about dev dependencies and everything. So for the timing, I'll just install it as an overall dependency. And you can see we have installed Sequelize CLI and we are good to go. Now let's see how we can actually set up Sequelize CLI. It's very easy to actually set up things with Sequelize CLI. Once you install it, you will see in your project, nothing will actually change. Only your project.json will change. I'll bring it here. Okay. Now you have to do a bunch of stuff. So we are in our source folder, right? You can see we are in our source folder. All of the actual folders and coding is inside our source folder. We are not keeping anything in the root folder. In the root folder, we just have env file, git ignore and everything. So what you have to do is, there is a command called as Sequelize init. It initializes a project. Now, in whatever directory you want to initialize your models and all the actual code is going to reside, you should execute this command in that particular directory. Let me repeat again. Our actual coding implementation are going to be inside the source folder. Here, all the logic is going to be there. So there is a command called as Sequelize init that initializes a Sequelize project. Okay. So it is also going to contain a bunch of logical stuff, that how database and configurations will be done. It will automatically give us that. And then later when we will be creating models and seed files and seeders and migrations using it, then also it will write a bunch of code for us. Now we don't want that code to go in the root folder because all of our logic is inside the source folder. So what I will say is, go inside your source folder. So you can actually see I'm inside my source folder. You can carefully see I'm inside my source folder, and inside your source folder, execute this command. So let's write npx sequelize. I'm writing the spelling right? Npx sequelize init, and let's press enter. The moment you press enter, the single moment you press enter, let's see what all it says. It says this is the Sequelize CLI version and everything. It says it created config/config.json. So we were already having our config folder. You can see we were already having our config folder inside which we were having our server config and logger config. Inside the, so it automatically detected that there is a config folder already, and inside that folder it created a config.json. More about this config.json in a moment. Then it created a models folder. So it automatically detected that we didn't create a models folder. So it needs a models folder. So it created a models folder. And it is giving you a path also. It successfully created a migrations folder. I'll talk about what is migrations, but you can see it successfully created a migrations folder as well. And it successfully created a seeders folder as well. You can see there is a seeders folder that it is created. And technically, after this integration, all of our major folder stuff is done. So how do you do this? You go inside the source directory of your project and execute npx sequelize init. As simple as that. It is going to do all of this stuff automatically for you. And you will see all of this magic in some more moment when we'll do more magic using it. Okay. Now, let's one by one talk about what all folders have been created and what are the use cases of these folders. But before that, I believe this much part is clear to everyone. Now let's one by one talk about what Sequelize CLI actually gave us. The biggest and the most important thing it gave us is the config.json file. It's a JSON file. It's not a JavaScript file. First thing that you have to keep in mind. What this JSON file gives us, it gives us configuration for 3 environments: development, test, production. So before we discuss anything else, let's talk about these 3 environments. So what is development environment? When you are a software developer, you are coding your project in your particular folder or laptop, in a particular folder inside your laptop, and you are making a project. Let's say you are working with some company like Netflix. Okay. Then you write some coding implementations. You want to build some features. You break stuff, you build stuff, and you want to test a bunch of things, right? Let's say the feature that you are building involves some kind of database interaction. you are still building the project. You have not completed it. So do you think when you are actually building it, you are testing it, it's an informal testing going on. Do you think the data that you are testing with or the database changes that you are doing, for example, you are creating a table, dropping some tables, doing stuff. Do you think when something is in development phase, do you think you should do it in your production database where actual users are also interacting? In one database, your users are also interacting because your application is already up, right? Netflix, a lot of people use, and Netflix keep on developing features. So should the developers of Netflix should the developers of Netflix use the same database for their testing and development stuff that the end users are doing? Your developers are making and breaking stuff. What if they break something on the production database directly because they are still creating it? It's a human mistake that can occur, right? That's why That's why you need a separate development database that we call as a development environment for database. And then think about it. Now your developer says that, yeah, I'm good. I have made the feature. Let's roll it out. Then your manager will come and say, hey man, let's wait. You say that you have developed it, but we still have to test it. Then what will happen? There will be some bunch of QA folks, quality assurance folks or testers. I'm not sure what's the exact difference between both of them, but both of them can help you to test your code. Okay. So there will be a bunch of QA folks. What they will do, they are going to test your feature. Now, maybe while testing your feature, there are some bugs. So should they test your feature again in the same database that the end users are using? No, right? Because if there are some bugs, you have to rectify that, right? That's why they need a separate environment for it. That is the test environment. They can't use a development environment because that development environment, every developer is going to set up the development environment in their own local laptop. So they can't share the development environment. And these testers also cannot use the production environment because your feature is still getting tested, right? So they need a separate database environment called as the test environment, right? And then at last, once everything is good, everyone is happy, you roll out your feature, your production environment kicks in where the actual users are going to connect and interact with the database. Now, what Sequelize CLI does is it gives us a configuration file where we don't have to put a lot of brain of ours. All we have to do is, currently we are not having any production or any test setup, so we can currently avoid it altogether. I'll tell you that how it detects that you are in a production environment and how it detects you are in a test environment. I'll talk about that, but for the time we can avoid it because currently we are developing, right? So the only thing that it is going to detect is a development environment. That's the default environment that it is going to detect. Now you can see a bunch of things. It says, first of all, let's read this. Dialect MySQL. Now, if you remember the docs of Sequelize, you must have seen this dialect somewhere. Can you see this dialect? Dialect is nothing but which database to connect to. Now, Sequelize CLI automatically detected that we are going to connect with MySQL. Most probably, what I assume is it detected it using the package.json because we have the MySQL2 driver. If there are multiple drivers, I believe it might just put some default database like MySQL and then you have to manually change it, right? But this dialect value is same as this dialect value that you can put MySQL, Postgres, SQLite, MariaDB, whatever it is, Microsoft SQL or something. So this mentions that this project's ORM, which is Sequelize, is going to connect to a MySQL database. Then this is the host. Host, what do you mean by host? Host means it is going to get the URL of the server where you have actually deployed your MySQL server. Now in my own machine, let me open MySQL Workbench, okay? It will take a while, I believe. So in my own machine, my SQL server, the MySQL server is running at localhost 3306. And you guys already know about what localhost can be replaced with. 127.0.0.1. right? So you have to mention the URL where you have hosted your database. Now this is a development environment. It is going to reside in my own computer. So it should contain the localhost address, and it will assume the default port. So for MySQL, the default port people put is 3306 only. So until or unless you have a change in default port, you don't need to mention the port here. Okay. This is the second thing. Now the next thing is database. Now this is going to be your database name. So if you remember your normal raw MySQL queries where we say create database and then the name of the database. So whatever name of the database you want to put, you can just put it here. It will automatically create a database for you. Okay. Then this is simple, username and password. So most of the time to connect to your database, you need a username and a password, right? Sometimes maybe let's say in your development environment, a lot of people don't set up a password. I have set up a password, right? So I will write my password here in the form of a string. Whatever is my password, I will write it here. And I will also write my username. Whatever is my username, I will definitely write it here, right? And just by doing all of this, we will be able to set up our development environment for our corresponding database of MySQL, right? So all we need to do is whatever is the database name I need, I can put that. This is already set. Whatever is my password, I will add that. Whatever is my username, I'll add that, and we will be good to go. Now you can see this file contains sensitive information. So we should not put this file on any GitHub repository or something. So we will come to git ignore and we will say source slash config slash config.json. Okay. We need to hide this file as well. We need to hide this file as well. You can see it grayed out. But when somebody will use our project, they need to also create this config.json file, right? So what you can ask them to do is you can copy this file and you can go to readme, and in the setup, you can mention the next step, that is inside the source slash config folder, create a file named as config.json and write the following code. Okay. If you are setting up your development environment, then write the name of your username, write the username of your DB, password of your DB, and in dialect mention whatever DB you are using. For example, MySQL, MariaDB, etc. Okay. If you are setting up test or prod environment, make sure you also replace the host with the date with the hosted DB URL. Right, that's it. So now the user will automatically understand that I need to come here and create a config.json file where I need to put my username and password, right? Then only everything will actually work, right? And this is how anyone can actually start setting things up. So what I'll do is I'll just create a quick commit. I'll come out of the source. I'll say git add all, git commit -m, added basic Sequelize and CLI related files, git push. Okay. So now if you will go here, if you refresh, now you can see the readme has been already added, and you can see in the readme we have very cleanly mentioned that what you need to do. And if you go inside source, if you go inside config, there is no config.json. So people have to actually themselves create it, because I don't want to push my config.json because it can contain some sensitive information. Now what I'll do here is, my username for my local MySQL database is root only. I'll just change my password. I don't want to show you guys the password. So what I'll do is, I'll just separately update it. Okay. And now I will not open that file again. Even if that gets opened, I'm still safe because it's not a very useful password for me, but still I don't want to show the password. Right. And this config.json, we are going to lock down forever. We don't need to change it until or unless we have to do some changes in the test or prod environment. Now the next folder is the most interesting folder that Sequelize CLI actually gives us. It is called as migrations. Now, if you come from a world of Django, Rails, or similar big frameworks, you might have already heard about migrations. Or maybe even if you have heard about it, you might not understand it, but don't worry, I'll talk about it. So this migrations is not something that Sequelize again itself does. Migration folder is used in many frameworks, right? Now, what is the use of migrations? In simple terms, migration files are used to do version control of your database. Think about it. You start making an app, you create a very small database, then you want to add more features, you update your database, add some tables, add some columns, do some indexing, then more features come up, you want to add more tables, more joins, more views and everything. More features come up. Let's say now, due to some feature something is failing, you want to revert your database to some old state, to some old configurations, all of this. So if you want to do version controlling of your database, you should use actually migrations. What migrations are? These are simple language scripts. For example, if you are using Node.js and Sequelize, then these will be JavaScript files. If you're using Ruby on Rails, then these will be Ruby files. In these files, you actually write programmatically that how to maintain versions of your database. There will be some version, every version will be having some unique number or some unique ID. You might be having 3 tables there. Then you add more tables, it will add one more version in it. Then you add few more tables, it will add one more version to it, and so on. How do you add a version? There is a command called as this Sequelize db migrate. The moment at any point of time you run db migrate, it creates a new version of your database. Okay. So that's what you do. How do you create migrations? You can actually do something like this. So you can see all of these commands. For example, you can do migrate undo to actually undo, revert some migration. You can do migrate undo all to revert all of the migrations. You can do migration status to get the status of all of the migrations, and so on. Similar to this, you can actually do migration generate, right? Or migration create. Similarly, you have migration create. So sometimes some commands will be having some alias command also. So instead of migration generate, if you want to do migration create, you can do that. And this will create a new migration file for you, right? And in that migration file, you programmatically mention what changes you might want to do, right? And a lot of programmatic things it will also mention for you. Sometimes something specific if you have to do, you might have to write some code for it, but still it does a lot of things for you. So if you have to do versioning of your database, you can actually do that. And just to prove a point that this is not something that I'm cooking up from myself, a lot of frameworks actually use that. I can actually show you that. So this is a Rails project. And if you go to DB and migrate, you can see there are a bunch of files. These are migration files. In these migration files, for example, in one of the files, I mentioned that in the users table, add a profile picture column, which is a string. Okay. In one of the migrations, I mentioned that you need to create a table follow mappings, which is going to have a follower ID and a followee ID, right? And so on. You can see. So it is like versioning, that once we made these changes in the database programmatically, then these changes in the database, and so on. And what it will does is it will do all of the syncing, all of the stuff automatically. Sometimes due to, again, it's still in development and a lot of features are still coming up, for a few associations we might have to do some extra work. I'll talk about what extra work you have to do. There is something called as db sync that we have to do. We will do that, no worries. But apart from that, most of the stuff is going to work like a charm, and this migration folder is going to be one of the most concrete and one of the most solid foundations that we are going to give to our project repository. Now, the next important folder that we got from Sequelize CLI is seeders. Now, what seeders do is, let's say if you want to put some default value to your database, for example, you are testing, you don't want to like separately, let's say you are making an e-commerce API and you have to test something, for example, with respect to some products. Now, in order to test it, you have to add, let's say 10 products. You don't always add products like doing insert into products and something, or maybe use a insert or create product API to actually write it. We generally use seeders file. What seeders actually do is they put a seed data. Seed data means starting data for your tables. We generally use it for testing purpose. We don't need seeders apart from very specific use cases, even in production. For example, you might need seeders for, let's say, assigning some roles. For example, your application might be having some roles, for example, normal user, seller, and then admin role. These kind of rollings you might have to do. Now, role is going to be something that is going to be there in your development environment also, test also, production also. So what you can do is you can create a seeder file for roles, where you will define what roles you need to mention, and you can run that seeder file and it will automatically populate roles in your database. So you don't have to manually go and say insert into do, then do this. So if you want to have some starter data, or let's say if you want to have a set of data that is never going to change in the table, you can definitely use seeders for that. Now, how will you write seeders? We will talk about that later when we will actually start the coding implementations and everything. But this is the actual meaning and use case of seeders. Now you can see even Django has migrations, even Rails has migration. You can actually read about Rails migrations here, right? So every good application, you will see people actually doing migrations and everywhere. And you can actually see whatever tech stack you have, you can see whether that has migrations or not. For example, let's see, Laravel is a framework. Do we have migrations in Laravel? I've never worked with it. You can see even Laravel has some kind of migrations as well. Cool. That being said, now you can see that inside my README, I have added this whole document that inside the source config, you have to create this file and everything. But technically, they don't need to create this file. Instead of doing something like this, all we can ask them to do is go inside the source folder and execute the following command. What's the command? npx sequelize init. That's it. When they will do npx sequelize init, they will automatically get the migrations folder and the seeders folders with them, along with the config.json file, right? By executing the above command, you will get migrations and seeders folder along with a config.json inside the config folder. As simple as that, right? And then if you are setting things up here and there, this situation should work. Also, we need to do one more step here. Go inside the folder path and execute the following command. We need to also make sure that they execute npm install, right? Npm install, or you can just do npm I, so whoever knows it knows it. And then in order to run the server, execute npm run dev. That's it. Okay, so these things will work. And now whenever we have to actually add some migration, so once we actually start building the project and everything, I'll talk about that, how you can actually add some migrations here. Till the time you don't add migrations, these migration folders won't pop up here, right? So make sure if you don't see migrations folder here, you know why you don't have a migrations folder, because the folder is empty as well as the seeders folder is empty. So most of the time the changes in the seeders folder and migrations folder are going to be done by a bunch of commands and a few coding implementations that you have to do. But you will see that a lot of things Sequelize will automatically do for us, and it's extremely powerful. So I'll just quickly commit it. And we are good to go. So we have our base node project template already set up with us, right? You can see a bunch of commands and everything. So people will be able to actually very easily understand what is going on in most of the folders. Now we have spent good amount of time in preparing our base node project template. Now what I'm going to do is I'm going to use this project template and I'm going to try to write a very basic CRUD API, very simple kind of a CRUD API. Why? Because I will show you the process that how you can get started with the same template and how you can actually use the Sequelize ORM and the power of Sequelize CLI. Okay. So all of these things we are going to talk about now. So the first step should be, this is the base template hosted on my GitHub. All you have to do, just copy the GitHub repository link. And what you have to do is you can do git clone. You can paste the link and you can see the repository has been cloned. You can see ls, sorry. My bad. Grab base. You can see base Node.js project template, base node project template. This one is ours, right? What I'll do is I'll just quickly rename it. Okay, one second. Da-da-da. So I will rename it to flights, something like this. Okay, so I've renamed my folder to flights. Okay, you can see everything that we need is technically here. I'll open this project in VS Code. You can see we have the starter template. We don't have node modules or anything, but we have all of our base folders. We don't even have our migrations folder, right? We have our models folder because when we actually prepared the base template, we didn't go inside the models folder, but models folder by default gives you an index.js file where it does a lot of things. We don't need to go inside what it is actually doing. It is just helping us to get the models out of the whenever and wherever we require. Okay. So first thing that you should do after creating this project, as also mentioned in the steps, is do npm install, right? Do npm install. So we'll do this npm install and very easily it will install node modules for us. Then we need to actually make a .env file. So vim.env, we'll do something like port 3000. You can see we have a env file set up as well, right? Then we need to go inside the source folder and do npx sequelize init. So we go inside the source folder and we will do npx sequelize init. Okay. So it says model slash index.js file already exists. If it throws that error, all you have to do is just delete that file for once and try the command again. Okay. It says config.json is also there. Technically it should not, because I guess I marked it as in the git ignore, didn't I? I marked in the git ignore. So is it present there? It's not, right? From where it is detecting config.json. Oh, sorry. Config.json it already created previously, and then when it was trying to create index.js, it failed. So no problem. You can, it's already giving you a resolution. Just do a minus minus force. You can do a minus minus force, and you can see everything is back again. right? You can see the index.js file also comes back. So in case you download the template and you get this error, just delete the index.js file, try again. You will actually do most of the stuff yourself, right? Now, what you can actually do is you can come to config.json. Now here you have to write your database details. I am going to write flights. So I'm going to name my database as flights database. You don't need to for the time care about what's going to be in the database or the architecture or the design of the database. I'm going to just create a very simple table and do very simple CRUD in this particular lecture. Also, I will just quickly add my password here. So I don't want to show it. And I'll just quickly confirm the password as well. One second. Okay, 1 second. Let me check what's the issue with the password. So now I've changed my password successfully. Now I'm not going to open that config.json file again. We don't need to open that again. And we have the basic boilerplate template ready for us, right? What we can do is we can do npm run dev, and it has successfully started our server at uh, port 3000, right? So here I have opened MySQL and I have done show databases. You can see currently there is no database with the name flights. There is one flight search db dev and that's different, but there is no database with the name flights. Okay. So what's actually going on? So currently by just mentioning your database name in config.json is not going to create a database for you. That is something that you have to always keep in mind. So if you go to Sequelize CLI, and if you go to the documentation, there is a command that will attract your focus, which says Sequelize db create. It creates the database specified by the configuration, and we can actually execute that without any issues, right? So all you have to do is just do Sequelize init, make the configuration changes, and you can start actually doing Sequelize db create. What db create is going to do, db create is actually going to create a brand new database in front of you, right? Okay, so let's try to do that. So here what I'll do is npx Sequelize db : create. Okay, as simple as that. If you press enter, let's see what happens. So it did a bunch of stuff. It loaded the configuration from config.json. It is using the environment development by default. As I mentioned, the default environment will be development. And it created a database flights. That means in the same MySQL session, if I will again do show databases, can you see now you have a flight database, right? And it's a brand new database that it actually created without any effort. Now, if you would have to manually create it, you would have done create database, name of the database, and then a database would have been created, right? And where it got the DB name from, if you specifically remember the config.json, right? I can actually show you from my Git history. So if you remember the config.json, this was the config.json, right? Here we write the database name, which was database development, and I changed it with flights. So from here, it is taking the database name. From here, it is taking the database configuration, that is the URL to connect and the dialect. From here, it is taking your username and password. And this is the development environment that it is actually working on. You can see very simply, it created a new database, but you will feel like, okay, creating a database is also not a very big hassle in our case also. So what's so special that I am like too much a fan of it? You will see that in a moment. But I believe how to create a database is technically clear to everyone. Now, every table is going to be called as a model. Every table is going to be considered as a model. So if you have to create a table, you need to create a model. Okay. So let's see for models, what do we have? We have something like model generate. It generates a model and its migration. Okay. You can also do model colon create. Okay. So now let's try to use this. And this is going to do wonders. You can do npx sequelize model colon generate, or you can also do model colon create. You can see here as well, right? You can do model create or model generate, anything you can do. There's no strictness at all for anything. Then you give a space and you give a flag minus minus name. This flag minus minus name tells Sequelize that what should be the table name, right? What should be the table name? Now, this flag minus minus name tells that what should be the model name or what should be the table name. So let's say I'm going to keep the table name as, let's say, airplane. I'm going to keep the table name as airplane. Okay, cool enough. Now, this is just the table name. But when you actually create a table in MySQL, you do create table, table name, and you put a bunch of columns and their data types also, right? How can you give that? Very easily you can give. After giving the name, you give a space and put minus minus attributes. You give minus minus attributes. Then you give a space again, and now you can start giving attributes. For example, my flight will be having a model number. Okay, my airplane is going to have a corresponding model number. So I can say model number, and this model number will be a column because it's a table, right? What are attributes in relational databases? Think like, see how verbose it is. In relational databases, attributes are columns, rows are tuples, or tuples are rows. So when you say attributes, that means you're defining the columns. So the first column name should be model number. And I want this to be of type string. So without any space, you put a colon and you give string. See, without any space, you have to give something like this, model number string. See, you have to give it without any space. From now, no space is required. Okay. So every airplane is going to have model number. For example, Boeing 707, something like this, right? Then every airplane is going to have some capacity, right? Capacity. Now, capacity is going to be a numeric value, right? How can you describe numerics? You can actually say something like, let's say integer. Let's try with integer. Okay. Let's say these are the two properties that you want to keep. That is, every airplane is going to have a model number and every airplane will be having some capacity. Okay. Let's keep these two properties. Okay. So let me revise. What did I do? I said npx sequelize model colon generate. This is going to create a model. Model means a table in our case. Space minus minus name airplane. This is going to give name of the table. Minus minus attributes space model number string capacity integer. Without any space separation, you give one column name, then its column type. Column name, column type. Okay. Simple things. Okay. Let me just press enter and let's see what wonders it can do. The moment I press enter, it technically created two files. First of all, it created a airplane.js and it created some number hyphen create hyphen airplane.js. Okay. Let's see what it created for us. You can see now in the models folder, you don't need to go to index.js. Index.js has its own set of code. You don't need to touch that. Airplane.js. Now, can you see what it has done for us? It created a class airplane automatically, gave us an associate function where you can actually do some associations. I'll talk about associations later. And it actually gave you the properties written here: model type, data types dot string, capacity, data types dot integer. Now you might be thinking, sir, okay, what's so special about it? If you will go to the documentation of Sequelize, the official documentation of Sequelize. Let's see how do you define models. Okay, let's go getting started. Model basics. Model definition. See, this is how you define models. This is how you define models. Now you can see this type of a thing that you had to do yourself is somehow getting done automatically by Sequelize CLI. You don't have to worry a lot. Now you will see here that, okay, first name, they're able to give some constraints also. For example, allow null false or something. But here you don't see any constraints. You can very easily do that. For example, I want to add some additional constraints here. What I can do is I can wrap it inside an object and say type data types dot string, and I can say allow null to be false. Now what will happen is it will say that in our model number, in our table, the model number should not be null. If you remember, we talked about not null constraint, that a particular column should not be null. In our case, this column will now not be null. As simple as that, right? So I'll talk more about these constraints when we will make some more complex logical stuff here. But you can see very easily it created a bunch of things here for us. Okay. Before I actually go to the migrations file and show you what is there in migrations, let's see after executing this command, did it actually created a table or not? So I'll go for use flights. And if I do show tables, you can see tables are not present. What's going on? So technically, by doing npx sequelize model generate, it doesn't create tables actually. It will just create a model file and migrations file. And that's where the logic of migrations actually come into the picture. Let's see what's there in this migration file. Migrations is like you do git add. Migrations is like you do git add, but it is not doing any git commit. Until or unless you commit, it doesn't make a version, right? And what did I say? Migrations are more or less like your versions in your tables. Okay. I'll show how those version history is getting maintained. But this migration file is going to tell you that in the next commit, these are the changes that will actually happen. In the next commit, these are the changes that will happen. Okay. Now currently, the changes that will happen is going to be around according to this up function. Up function. Okay. What does this up function says? It says await query interface. What is query interface? If you don't use Sequelize, for example, you don't want to use any ORM and you want to by default in a raw fashion connect to MySQL, then you need to actually set up a query interface object that will actually connect to MySQL and you will write raw queries. But because you are using Sequelize, so Sequelize does this query interfacing automatically. So it has this query interface and it says create table, which will be airplanes. Name of the table will be airplanes. And you can see these properties. Now I just added model number and capacity, but Sequelize automatically knows that no matter what, you will definitely need an ID property that will be a primary key. It should not be null. It should be auto increment true, type integer, and there should be created at and updated at, because otherwise you won't be able to see when this data was created, when it was not created. Sequelize automatically does this. And Sequelize is showing that in the next model commit, there will be a table created with all of these properties. If you want to make any changes, this is the time to make the change. If I don't want to have created at or updated at, I'll remove it. I'll remove it directly from here. But if you want to have any changes to be done in your table, this is the moment you actually do that, right? You should not do it like you can technically, once you make a commit, then you can actually revert things. But for that, you have to make another commit. It's like git thing. Once you make a commit, then you can revert things, but you have to do a bunch of stuff there as well, right? Although it's not very strictly like git that every time you cannot go back and a lot of things, but it's still doing some kind of versioning. So what this migration is telling that there will be a table created, right? And all of these things will actually happen in that table. Do you want to do any change? this is a good time to do a change. If you don't want to do a change, we don't care. Okay. So let's say what I'll say is that now if you will see, I added a bunch of constraints on model number here, right? So what will happen? You need to add those constraints here as well, because what Sequelize tells us is that there are two level of constraints that you can actually put. One is database level and one is JavaScript level. When you just mention type string allow null false, okay, let's do the same thing for capacity also, that types is integer and allow null false. Okay, so I did for both model number and capacity. What will happen is it will put a JavaScript level constraint that when from a JavaScript code you will try to add an airplane without a capacity, it will throw an error. But if you will put your constraints here also, then it will put a database level constraint also. That is when the table will be created, no, that table will also be having that constraint. Let me show you. It might sound confusing, but let me show you. So what I'll do is I'll just add another allow null property to be false, and just see very carefully. I'm adding allow null to model number, but I'm not adding allow null to capacity. Okay. Let's see what will happen when we will commit the database. Now you might be thinking, sir, you are talking from a very long period of time. You will commit the database. You will commit the database. How will you commit the database? So in order to make the commit, that means in order to make the version, one very simple command is npx sequelize db migrate. What db migrate does is it actually, whatever are your pending migrations, see, this is a pending migration, right? It is created, it is not applied. Think about it. Creating and migration and applying and migration are two different things. Creating and migration means you have created a code with which you can still make changes. When you apply that migration, that gets applied to the database, right? So if you do npx sequelize db migrate, it applies all the pending migrations to your database. You will think that how it knows what are the pending migrations. The solution is very simple. It actually tracks that what all migrations are actually added using this unique migration number. You see this number 2023-0502. This is the date, and then this is technically the timestamp that it is trying to get. So based on this date and timestamp, it creates this unique number, and based on this unique number, it actually tracks which migration has been applied. The moment I press enter, see what it is doing? It says loaded configuration file in the environment development. It is migrating this migration, and then it migrated. If you remember previously, I was not having any tables. If I do show tables now, I have one airplanes table, and I have Sequelize metadata as well, right? Sequelize metadata as well. If you will say describe airplanes, now let's see what's happening. Field id type int, should it be null? No. Key, primary key, default value null, extra auto increment, all of these things are mentioned here. Model number varchar 255, can it be null? No. Nothing else. Default value will be still put as null. If you want to put a default value, no, you can also put a default value here. Okay, I'll show you all those properties as well. But now you see the capacity, we did not put the allow null constraint in the migration file. So you can see capacity can be null. Capacity can be null. So by putting allow null here, you are putting a JavaScript level constraint. But if you have to put a database level constraint also, then you have to put that in the migrations. That is something that you have to always keep in mind. And this actually created a table for us, right? And it also created another table, Sequelize meta, which is nothing but having a name, having a type, and this. So if you do select star from Sequelize meta, you can see it just stores the name column, which is having what last migration you actually applied. And if you see your airplanes, currently it is of course empty. Currently it's of course empty. So you have created a table. Now you might be thinking, oh shit, I made a mistake. I didn't want to create that table. I want to revert. What should I do? Don't worry. You can undo the migration. So whatever was the last migration, you can undo that. And if you want to undo all migrations, you can do undo all. So let's try to run undo. Okay. So I'll say npx sequelize db migrate undo. The moment I press it, it will revert back everything. And now if I do show tables, you can see this table is present, but your airplanes table is gone. And if you see the content of select star from Sequelize meta, you can see this is also empty because that migration has been reverted. So now you are able to technically create versions of your database schema. And let's make a change. Now, I don't want the name to be airplanes. Let's say I want the table name to be airplane because here I would like to keep singular. For example, generally you have to keep your models singular. Okay. You try to keep your models singular. Okay. But when you actually create the table for them, you keep them plural. It's a general notion that table should be plural, but your model file should denote it as singular. So see, when I gave it the command name airplane, it automatically pluralized it. So that's why it is plural here. So I would not change that. But let's say I forgot to add allow null here. So let's add, instead of allow null, let's add, let's say default value to be 0. Okay. Now the capacity of any plane that you will add, if you don't add manually, will be default value 0. So now I again changed the migration. Now I'm good to go. Let's migrate again. So if you migrate again, all you have to do npx sequelize db migrate. Boom. If you do show tables, back. If you do describe airplanes, can you see capacity now has a default value 0. The only thing is, if you will undo a migration, see, so what happens is when you're adding a migration, this async up function actually applies. When you undo the migration, async down function gets applied. Down function says drop the table, right? So if in your undo migrations or in your async down, you are deleting a table or dropping a table, of course you will lose the data. So make sure you are careful about that. And now we have a database setup in front of us, right? Now let's say if somebody else, for example, 5 people are working in a team, you have 5 migrations file, you added one more migration. That means you added, let's say, one more table. Migration can add a table, migration can alter a table also. So of course, I believe you are able to understand that much complexity. So let's say in a migration, you added a table. Now your other 4 members, if they want to have the same table, how they will get it? They will just do git pull. They will run npx sequelize db migrate, and whatever are the pending migrations in their system will actually shoot up. And that's how very easily you can maintain versions for your models and your database. I hope this particular point is making sense to everyone. There might be a doubt in your mind that is there any reason of giving database level constraint or not? Think about it. If somebody is directly inserting some data in your database, then you definitely want database level constraint. If you are sure that no one can ever directly enter anything in the database, then this JavaScript level constraint is enough. But I believe database can be, for example, you have to take the backup of the database. Same database might be used by some other language. For example, let's say there is a Ruby project that also interacts with the same database somehow. Then you need database level constraint. You will definitely love to have database level constraints in that case. Otherwise, these program level or JavaScript level constraint are enough. When you will actually try to make a airplane with a JavaScript code and you don't give a capacity, it will automatically take a default value false if you put here. Sorry. Default value 0. If you don't put a default value 0, JavaScript will not pick default value 0 from here because this file is only for DB interaction. JavaScript will just read this file. I hope this point is making sense to everyone. You might be having doubt about the types that actually are present here. For example, data type dot string, data type dot integer. What data type actually it is picking? So based on your database or dialect, for example, MySQL, when you put string, it takes varchar 255. If you have to do varchar 100, you need to do string 100, right? Let's say if you do integer. So for example, you can see here it is written database dot integer. If you do integer, it takes the default integer. If you have to do bigint, you can do data types dot bigint in Sequelize. So you can modify the data types according to your need. So this is definitely a very helpful page. They have a very, very good documentation. Sequelize has one of the very good documentation. So you can actually check out that for any data types level information. Now, what if you make changes to your model? If you make any changes to your model, technically you should create a migration for it also. Otherwise, on JavaScript level, you will see the changes going on, but on the table level, you will not see the changes going on. So for example, let's say if I put a default value to model number default value to an empty string. Now, after doing that change, if you do describe airplane, you can see no default value has been added because it doesn't make changes to table level. It is only making changes to JavaScript level stuff. That's why models will only be handled at JavaScript level. Migrations are actually porting your changes to databases. Now guys, everything in the database level stuff, what we are doing here, you can do without migrations also. Sequelize give you support for establishing everything without migration. There is something called as DB sync in Sequelize. Whenever you actually create a model and you have done the setup using raw Sequelize, you can actually do something called as DB sync, right? For example, any table sync or whole DB sync also you can do Sequelize sync like this, and it will also make changes to the tables. The only problem is this doesn't maintains any versions of your database schema. If you have to make some incremental changes, you won't be able to do that. What change actually, for example, let's say you added a table, then you added another table, but the second last table actually was problematic for you. So you won't be able to understand because you don't have proper versioning, right? Because now if you have versioning, what you can do, you added a table, you added another table, and second last table was having a problem. You will do undo once, you will do undo again, you will make changes on this particular migration again, then you do db migrate again. So you can actually move back in time and update things up, right? But here you won't be able to do that. Or maybe if you want to rectify, you don't want to move back, you can create another migration that can rectify the other problem. So you'll be having proper versioning of what is happening with your database. Here you won't be able to do anything like that. Now let's say if you have to write raw queries, then you can do something like sequelize.query and write a raw query like this here, right? So very simple way to write raw queries. Now you might be thinking that this is not so powerful, but technically it is extremely powerful. You can see there is a concept called as operators. Now operators will make your life crazy. Why? Let's say you want to do something like a is equals to 5 and b is equals to 6. So you can write a where query, and inside that where object you can require the op object, that is the operator object, and in a square bracket like a symbol you can give op dot and then whatever array you will pass, it will put a and query on that. If you do op dot or, you can do something like this: op dot equals, op dot not equals, op dot is, op dot not, op dot or. op dot gt means greater than, gte means greater than equal to, between means between 6 and this. You can see you have like operators, regex, not regex. You think about it, you'll get it. It's like that. You have your in queries, your and op or queries, everything you have, right? Everything is available in Sequelize. It's not short on anything. It's nowhere less powerful until or unless you have to do joins of 10 tables. Then you will feel like writing raw queries must have been much easier. Otherwise, Sequelize is going to do most of the stuff very easily for you. So now technically what we can actually see here is that we have a city model with us. Now, if you remember that whole folder diagram that I created, Controllers should never talk to directly to models. Services have business logic. They don't directly talk to models. So who talks to models? Your repository talks to models. And that's why we are going to write a bunch of code in our repository. So in our repository, there is an index.js file. What I'm going to do is I'm going to create a new file called as crud repository.js. Now just think about it. There can be complex operations that you have to do. But for example, let's say you are making a movie booking application. You have a theater model, you have a movie model, you have a user model. Of course, for every model, you should be having a create, read, update, and delete function, right? So why do you want to make same effort again and again? If you will go on the internet, you will watch tutorials, you will see people actually writing create, read, update, delete again and again for multiple models. We don't need to do that. We'll just make a generic CRUD which can do the basic stuff. And if you want to do anything complex, you can write your own functions there. I'll show you how things will work. What I'll do is I'll make a class CRUD repository. This class is going to take a constructor which is going to have a model property. We'll say this dot model is equals to model. Okay. So what is done here? We have actually created a CRUD repository class. The constructor of this class takes some model and it stores it in our variable. This dot model is equals to the incoming model. Okay. Now what I can do is I can write a function async create. Async create. This will take data. Now let's see how Sequelize work. If you go for query, generally if you insert in MySQL, you do insert into table, then columns, then values, then value of those columns. If you have to do that in MySQL, you just have to do model name dot create and pass the data pointers that you want to add. It's a promise based API. You can just directly get it. So I'll say, let's put a bunch of try catch. I'll say const response is equals to await this dot model dot create data and return response. Can I say that? Right. As simple as that. You can do something as simple as that. Right. And now whatever is the model, let's say you have a movie model or a theater model, anything, you can just directly use this generic class there and things will start working for you. Now what you should do in the catch, right? I'll import my logger. Is equals to require dot dot slash config. Okay. And you can say logger dot error, something went wrong in the CRUD repo create function. Okay. And what I'll do is from here I will throw the error also. I will throw the error also because I want to catch this error in the service layer, and then I will manipulate, like you will see me doing those logics. I will manipulate this error more logically and try to form some custom error objects and everything. But for starters, everything is currently there for starters so that we can create a basic CRUD API. This is currently there for starters. This create function can help us to create some data. Now I'll copy this, paste it here, and I'll say destroy. If you want to actually delete a data, let's see, delete. If you want to actually delete something, you can do model.destroy, where something is equal to something, right? So here you can do something like this dot model.destroy, right? This destroy function actually takes an object as an argument. And if you have to put a where query that delete from table where something like this, right? So you can do a where query like this in Sequelize. If you have to do a where query, you can pass an object and you can write where, and then where this x is equals to y, you write it like this, right? So where If you want to write x is equals to y, you put another object. You say id is the data that is coming up, right? And you can see how where works. So if I query for where, so you can see if you want to write delete from post where author id is equals to 12 or author id is equals to 13, you do post dot destroy. Then you want to write a where query. Where query always goes inside a object. Then you put where, then whatever is your condition after where, you put it in the object, right? You can see more where queries here and there. Now you can see select this from posts as posts where post dot id in this. So if you have to see that id should be present in one of the arrays, it should be equal to this. If you want to do id should be equal to a particular value, you can do something like this, right? So writing where queries is very simple, right? You are writing technically object oriented code, model dot destroy, and then pass the custom object that you want to build the query for. As simple as that, right? Now I will write one more function. I'll copy paste everything here and I'll say get. I'll say get. What the get function is going to do is, get function will do something like this for us. Select star from airplanes where id is equals to this, right? So you want to do, let's say, query on some id that is the primary key. So you can say this dot model dot find by pk. What is find by pk? Find by pk means find by primary key. So whatever is your primary key, it will put a where query on that primary key data. Okay. So this is going to do select star from table where column value is equals to this, and this column is the primary key column. But let's say you want to get all of the data, select star from table. That's it. No filtering, nothing. So I'll say get all. I don't need to pass data because there is no filtering to be done. And there is a function called as find all. See, let's go. Find all. Let's see this one. Post dot find all. And then you are putting a filter of where. If you don't put a filter, it will just do select star from post. Okay. Let's do find by pk. Let's search it separately. Find by pk Sequelize. Okay, you can see these are all the query finders. Find all. The find all method already is known from the previous tutorial, that is this querying tutorial, right? It generates select query which retrieve all the entries from the table unless restricted with a where clause. For example, you can see they are restricting it with the where clause here. Find by pk obtains only a single entry from the table using the provided primary key, right? So it will give you always a unique record. Find by pk will always give you a unique record. Find all will always give you an array. Okay, it is always going to give you an array. Find one will also give you a unique record, but here you can fetch that unique record based on some other columns and some other conditions and so on. You can see there are a lot of functions. You don't need to remember all the functions. Once you start using them, you will get a hang of it. Okay, so you are doing get all for this. Okay, and let's do for update. So for update, we have a update function. You can see this dot update, whatever value you want to update with, you can update. And for filtering, you can do something like this, right? So copy, paste, update, right? Now update is going to take a ID as well and the data as well. Now you can do something like model dot update, right? Now with whatever data you want to update it, you can update it that data, and filtering can be done on where ID is the given ID. Okay. And just to mention, data is a object, right? Which will be having the column and the value and so on, right? So data that you are passing should be an object. You can see this is a object here. This is a object here, right? Cool. And you can see a basic CRUD is ready in front of us. A basic CRUD class is ready in front of us. What I can do is I'll say module.exports CRUD repository. As simple as that. And this CRUD repository is going to really help us in avoiding a lot of redundant code. I'm going to show you that in the next part. Now, if you actually remember, I talked about the fact that nobody else will directly do a query. Query related stuff will always reside in the repository. So here you can see all the actual queries I'm writing in the repository. So whenever I have to write any raw query, any custom query, joins using Sequelize, anything specific related to queries will only go inside this file. Okay, cool. Now what you can do is, let's start making our first, this was our CRUD repository, right? Now let's make a new repository called as airplane repository.js. Now airplane is going to be a simple CRUD. I can add a plane, I can remove a plane, I can delete a plane. Sorry, I can get a plane, I can update a plane. So now wherever there will be a simple CRUD, no, I'll do just this. Const CRUD repository is equals to require CRUD repository. Airplane repository extends CRUD repository. Constructor, I'll get the model, right? So how can we easily get the model? You can see inside the model, we have the corresponding index.js file. Again, you can just do require / models. And here you can say airplane model. Okay. You can say airplane model. You can see you are actually doing a return for module.exports for this class airplane, right? So let's come here in the airplane repository. Now in the constructor, all you have to do is, if you carefully see, your parent class is CRUD repository. The parent class constructor expects a model. I'll do a console.log, or we can do a console.log later. Let's see. But for the timing, you can call the super keyword. Using the super keyword, you can actually call the constructor of your parent class, right? And there you can actually pass your airplane model. That's it, right? So let's do one thing. 1 second. It doesn't redirect you currently, but the syntax is correct. We'll get it. We'll get the airplane model. And all you have to do is now is module.exports airplane repository. Now all the basic CRUD functionalities will be automatically given to airplane repository. If you want to add something else, for example, async some raw query, and you want to write some raw query for your database, then you can write that raw query here. But the other basic functions are already written, and those are generally very useful, right? Because a lot of things that you will see in backend is basic CRUD only. It's just that the complexity of the database, complexity of the API calls increase with increase in business requirement, but a very big part of it is definitely CRUD, right? So having this CRUD repository will definitely help us to avoid any kind of redundant code. Now let's do one thing. Let's go to services. And before we go to services, let's go to index.js. Now here what I can do is airplane repository require / airplane repository. Okay, looks good. Now anyone can just directly get your airplane repository. Okay, now you have services. What you can do is you can create a new file, airplane service.js. Okay, now if you remember, controllers pass on the call to service. Services use repositories to interact with the database. Now currently this is a very basic thing, so there won't be much business logic. But when you will make a very complex thing, for example booking something, that will be fairly complex. In that case, this service file will be having a bunch of logic. But currently, because it's a basic CRUD, we are just going to create, let's say, an airplane. There won't be much business logic, so don't get amazed with that. We'll write airplane service. Okay, we have a constructor, right? And now technically you can even avoid using a class here if you want, because I'm not making a CRUD service that can do all the basic stuff already. If you want, you can create it. I am not creating it. At least in this tutorial, I'm not creating it. So you can even make a function if you don't want to make a class. So let's make a function only. Let's say const require dot dot slash repositories, and from the repositories I want to require airplane repository. Now I can write a function const let's say something like this function, and let's name it as create airplane. Okay, this function is going to take a data property. I'm going to have a variable const airplane repository is equals to new airplane repository. I'll create the new airplane repository object. I can keep it global also. If you want, you can keep it local also. I don't think there won't be much of a difference in terms of performance because JavaScript has its own garbage collector. Now you can put a try catch, right? And then you can say const airplane is equals to await. Now you need to make a asynchronous function await airplane repository. Now you can see it will automatically get the access to the create function because its parent has a create function, right? Create, and you can say return airplane. Otherwise, let's say if you got an error here, again, error handling we will do in a more sophisticated way in some time, right? Currently, you can see there is no error handlers here. I'll do more error handling in a more sophisticated way in some time, right? For the timing, I'll just throw that. Okay, let's understand the basic functionality first. Now you do module.exports and you can export your create airplane function. As simple as that. So currently there is not much business logic, as I said, because it's a very simple thing. But the moment business logic becomes complex, you will see very fat services. Okay. Now I'll go to this and I will say airplane service require airplane service. Okay. So from the index.js of airplane service, I'll require this. And now time for controller. Let's make a new file airplane controller.js. Okay. Now here I need to have our service because we will always interact with the service. Right. Airplane service. Now we'll write a function create airplane. This will be an asynchronous function. It will have access to the request object and the response object. Okay. And from here I'll do module.exports create airplane. Now, how do you create an airplane? You can say try catch. Now, if you want to create an airplane, how the API should look like? The create airplane API will look something like this. It will be a post request with slash airplanes, and the data will be coming inside request body. Request body will be having data like model number as something like Airbus 320 and capacity is, let's say, 200, something like this. This kind of a detail will come inside request body. Okay, now one very interesting stuff is going to happen, but for the timing, let's see. So what I'm going to do is I'll say const airplane is equals to await airplane service dot create airplane, airplane service dot create airplane, and I need to pass this body, right? I need to just pass this body. So I'll do model number as request.body.model number, and I'll do capacity as request.body.capacity. Okay. Once you got the airplane successfully, you will say return rest.status. Let's get our HTTP status codes. Okay. I'll say status codes dot created. Okay. Dot JSON. I'll say success true message successfully created an airplane. Data will be having the response. Error property will be empty because there is no error as such. Okay. Otherwise, if service actually threw an error, again, as I said, we will do more sophisticated error handling. For the timing, what we will do is rest.status status codes dot internal server error. We'll say something went wrong on the server. There might be issue with client, but again, we'll do more sophisticated handling. As I said, currently I'm just preparing a basic CRUD API, or at least one of the part of the CRUD. .json, and I'll copy this object from here. I'll say success is false. You can say something went wrong while creating airplane. Data is now going to be an empty object, and the error property is going to have a error parameter from here. As simple as that. You can see this is the controller that we have. We just called the service. See, nothing more, nothing less. We got the request. We passed it on to the service. Service is going to do all the computation, do the DB interaction with the repository and everything. Give me back my airplane. And I'm going to just, this is the airplane. And then what controller does extra is structure the output response. So see, I'm doing all the structuring of the response in the controller only. This is the only use case of controller. And that's it. You can see a controller is in place also now. Now, in order to trigger this controller, we need to register it in a route. So if you go to routes v1 index.js, you can see these are the routes, right? So I can make a new file, airplane routes.js. I can say const router is equals to require. First of all, let's require express. You can directly do also express.router, but okay. Const router is equals to express.route. Okay. So we have our router in place. We'll say router.post. If somebody gives you a slash airplanes, you are going to map it to something, right? What something? Require your controllers, right? And if you go to your controllers, airplane controller, you have not registered it here. So let's do airplane controller registration. Require airplane controller. And now you can see very easily we can just import it. Airplane controller. We will say airplane controller dot create airplane. That's it. We will say module dot exports router. Okay. Now you come to v1 index, and now what you can actually do is info controller was just a sample. So you can actually say airplane routes is equals to require airplane routes, and technically we don't need to do airplanes. We'll do just a slash. And now what we can say is that router.use. So if anyone will give you a route that starts with slash airplanes, you can mount your airplane routes here. So if somebody wants to make a post request, let's see what will be the flow. In index.js, they will say localhost 3000 slash API. For slash API, you go here. Sorry. For slash API, you go here. Now slash API slash v1. So for slash v1, you go here. Slash v1 slash airplanes, you go here. And now it's a post request. So slash airplanes slash nothing is like what? Creating, right? Creating an airplane. So this is technically referring to slash API slash v1 slash airplanes, which is a post request, right? As simple as that, right? That's the level of segregation you can see we have done. So all the airplane related routes will go here. Then other resources, if you have, they will be having separately. So you will always know that where your code is actually residing. Okay. And this looks good to me. This looks technically good to me. There is only one piece of thing left that is going to break the whole code, which is something here. So I'll tell you what is the problem currently already. Currently, your code will not be able to read request body. Let me show you. Let's run the server. Okay. You can see I have run the server. I'll start Postman. Till the time Postman is coming up, I'll again show you the mechanism. See, somebody gives you a request to slash API slash v1 slash airplanes. So in your routes index.js file, you are mounting slash API to API routes. Then slash v1 to v1 routes. Then slash airplane to airplane routes. In the airplane routes, you can see there was nothing beyond slash. So it comes here and you're going to map it to controller, that is create airplane. Controller calls the service. Service calls the repository, and airplane repository internally calls thread repository. So you can see the whole level of segregation that is there. Now, what I'll do is I'll create a post request on localhost 3000 slash API slash v1 slash airplanes. And inside the body, you can use this URL encoded form. You can even use a raw and send a raw JSON, but you can use something like this. And now we need to send a model number that can be, let's say, Airbus 320. And let's say capacity. Let's see what the capacity of Airbus 320. I guess it's Airbus A330, not just 320. It's Airbus A330. Maximum capacity 180 it is. We'll say 180. Okay. So now you can see I am not sending the data in query params. I'm not sending the data in the URL params. I'm sending the data in the request body. The moment I send it, something went wrong while creating the airplane. And technically you can see everything is logged. So not this. You won't see much problem here. Why do you won't see much problem here? Because actually everything got crashed just here only, in the controller only. And you can see in controller I have not done any logging. So that's why logging is generally very helpful. But I can show you what is the problem. Console.log, if you do request.body, okay, if you send it again, request.body is undefined. By default, Express.js doesn't know how to read your request body. And there is a very simple thing to handle it. What you can do is, now, whatever are the incoming requests, you need to actually mention Express.js that in the incoming request, if there is a request body, please read it like a JSON. Okay. Now, in order to achieve this, in earlier versions of Express used to have an inbuilt library. Then after some versions, they extracted out in a separate library that got very famous, named as body parser. And after some backlash, because they segregated it out and people wanted it in the same library Express, they brought it back inside Express. So now you can see body parser is a separate library also, but you technically don't need body parser now. Express again has got back its implementation. So all you have to do is, before you actually start registering any routes, you can do app.use. Again, app.use is going to register a middleware for all the upcoming routes that are mentioned below it. Express.json. Let's read about it. Express.json returns a middleware that only parses JSON and only looks at the request where the content header matches the type JSON. So what it does is it helps you to actually parse the incoming JSON request body. Without it, Express won't be able to parse the incoming request body. And you need to do one more thing. Express dot, there is something called as URL encoded. You can see what is URL encoded. Returns middleware that only parses URL encoded body and only looks at request where the content type header matches the type option. And you can see form URL encoded. So if you want to read about what is URL encoded, I guess that's the correct spelling. This is called as URL encoded, right? So sometimes there might be some special characters in your URL that are encoded in a particular type of encoding. That's called as URL encoded. So in order to make sure that you also read URL encoded stuff in the request body properly, you need to add this middleware. This is a part of the one-time setup. You don't need to do it again. This function actually takes an object as an argument that has called a property extended. You can mention it as true. Now, what is extended true? So you can put extended true or extended false. It doesn't matter a lot because the extend option allows you to choose between the parsing library, that is either the query string library if you put false or the QS library. So it is just for a library choice. If you will put it false, it will choose different library. If you will choose it true, it will use different library. As far as I know, there are not much of a difference, but I have also not explored very in depth. Like I never got very in deep into it because when I was learning Express, body parser was a separate package altogether. So I thought it's a third party thing. So no point of going that deep, but technically you can try to read about it. For example, let's read it now only. Query string versus QS library. Let's see what are the differences. Now let's see. To be simple, query string cannot parse nested object. Instead, it will be presented in a square bracket format, while QS can be parsed in nested objects, right? So you can see there are methods present here. So let's, for true, it uses QS library. See, so that's why most of the time you will see people actually putting extended true, because then also it gives you functionality to read very nested objects. But again, you don't need to put a lot of brain here. Now, if you see, the server started itself, and the moment I do send, if everything is correct, it should work. And boom, voila. We have successfully created an airplane. ID of the airplane is 1, model number Airbus A320, capacity 180, updated at and created at this. And if you go to MySQL, select star from airplanes, we have our first very beautiful entry of our model number and the capacity of our first airplane in the database. And that's how we have implemented our first CRUD API, technically just the create of the CRUD API. Now implementing rest of the stuff is going to be pretty cakewalk, but I believe this much logic is making sense to everyone. Now let's do one simple thing in order to understand the whole incoming flow, how the pipeline is downstreaming. Let's do this. So let's start with API routes. Okay, we will do console.log inside API routes. Okay, I'll do a bunch of console.logs. Okay, then let's go to v1 routes. Inside v1 routes, then let's go to airplane routes. Inside airplane routes, let's go to controller. Inside controller, let's go to service. Inside service, and then first of all let's go to an inside repository. Let's do this inside repo. Okay, let's see if the server is running again. Okay, server started running again. Now let's make a request. Let's add one more airplane, Airbus 828, 880, Airbus 880, I guess. Okay. A380 Airbus A380. Let's make. So model number Airbus A380 and capacity is 520. Okay. Let's make a post request. Send. You can see it created another airplane. Let's see what's happening. So you were inside airplane routes, then you were inside V1 routes, then you were inside API routes. This was route registration. This was route registration. Then this got printed. I guess I didn't save the controller file, did I? Okay, I didn't save the controller file. That's why it's not printing inside controller. It's printing that request body. But this is getting printed from the controller. From controller, you went to the service. From service, you went to the repository. And in the repository, what are you printing? Insert into airplanes, ID, model number, capacity, created at, updated at, and with a bunch of values. So it's actually internally executing a SQL query only, but in a more object oriented way. So just to mention again, when you actually do /API, so whenever there is an incoming request, right, /API is going to make sure that if the request starts with /API, you are going to mount or you are going to register API routes. What's inside API routes? /v1, that after /API, if somebody has /v1, then you are going to register the v1 routes or mount the v1 routes. Inside the v1 routes, you have written /airplanes, that after v1, if somebody gives /airplanes, I am going to mount airplane routes. And after that, just slash. That means after airplanes, if there is nothing and it's a post request, you're going to call the controller. In the controller, you are actually calling the service. See, this is the service. And in the service, you write your business logic. We are not having much business logic because this is still tutorialish. But when complex things will come up, this will be having business logic that internally calls the repository. So service is not going to directly communicate to the database. Service will be actually communicating with the repository. Repository handles all the database related stuff and then gives you a response here. This response is again then given back to controller here, and controller returns back this response. Currently, I don't have any middlewares in place, but you can also set up middlewares in place. I'll show you that in the next part, that how you can actually set up middlewares in place and how you can do some better error handling that we are going to cover in the next part.